Today is the day 2 for the advanced operators training. So I will go through the agenda again so that you are aware that what are we going to do today again. Yesterday we have went through the alpha concept, HMC, manage basic HMC. These are more on hardware. So you need to do all these steps. Make sure that you get the right advice first. Don't just go and change the alpha for any of the server. And after that, the decision also go through the IBMI, the access family, and the client security concept and overview. Those are more into the operating system, right? System value, security, resources, and so on. Also, we talk about the authority list and the management of the concept. Today, I think he's going to talk about the work management, which means he talk about the subsystem, the job processing, the submitting of job, and programming concept. So I will leave it to him to decide on the timing, and these are just guidelines for us today. Then afternoon, you continue again with the work management, more into the interactive job and other job, batch job, and so on. And after that, submitting and tracking a batch job and the programming concept. So today is a lot more on the jobs that we are talking about it on the AS400 operation. Yeah. Tomorrow we were talking about the CL programming and so on, which I will go through tomorrow. The things that we have a customer asking, like how to retrieve the user profile if they lost everything. I think the best practice is to create the second QSEC officer password, ID and password, or the third or the fourth, and set the ID to not expired, and make sure that you put all this into the envelope and seal it somewhere. It's not known to the IT, is it? So these are all the rescue method that we need instead of going straight to the HMC. So most of the best practice that we have to implement are those second QSEC officer password, third QSEC officer password, and you seal it somewhere with the security head. Only he knows about the ID that someone else can access in case the security head of whoever is not accessible. So we have to prepare for the worst case. Anything can happen. Yeah, so we must know how to rescue our own server. Second is this topic, although we don't talk about it, the backup is supposed to be the basic AS400 operation, but make sure that you backup, even though AS400 is so stable, but entire system backup is still needed. If your system is so critical that you couldn't shut down to do the backup, there's a good thing that you better prepare for the HA. HA can be a alpha, can be a server. We have done a lot for customer, and we can share with you how to do it. Quite a number of customers can do their entire system backup from the HA, because HA you may have exactly the same as your production. So you can schedule to back it up from there. So entire system backup is still needed, no matter what happened. Don't leave it without entire system backup. Yeah. Because some of the people don't do the entire system backup, or some just backup while active. Recovery quite challenging, for the daily restore. Yesterday, Jason had talked about some features on the 7.4. So should you wanted to look into the 7.4 version, you can also come to us and how to include all this RCAC and so on. Yeah, we got a Power 9 here. So those are those features that you can actually plan and implement it later. This one, I didn't see any interest. I hope that we can create some interest, that we can build AS400 group and AS400 forums, which more things that we can share, like what we can do and what we can do better, to protect and to make use of the AS400 features and so on. So if you have a big group and whatever request we have, I think IBM also will look into it. So if should you have some new request that is not inside even the 7.3, 7.4, we can also suggest. If we have a big forum. So we also can have forum to talk about the topic that we can help others. Yeah, everybody can actually play a part in this forums, which I'm suggesting. Any nomination for the forums are welcome, and you can actually send it to the chat there. You can send the email to us, because I can see that a lot of questions coming, and somebody we may not understand unless we have a forum to discuss about it. That we can have a group, and then we can work out. Nowadays we don't need to have a physical meeting, We can have Webex meeting to discuss all this and what will be the next topic that we should share it with the AS400 group. The AS1 Riot is very important also, not just Riot Malaysia. Those are people may need help. Yeah. So we would like to see some nomination that we can actually work with them, and then we form the team, and we support the Malaysia AS100 team, and also can talk about the future event and training that needed. Maybe somebody may need the guideline on the RPG programming, CL programming, and so on in more details, and whether we can find the people to do it. But these are things that we need the interest, So if you have enough interest, like the big group, we are more than happy to plan for all these specific topics. Okay, that is what I want to talk about today. I will pass it to Jason to continue with training. Thank you.
Okay, thank you, Mr. Lee, and good morning, everyone. Okay, let me bring up the chart right now. Okay. So this is a slightly touch up agenda for today. So we will probably, due to the, because the class was tailored for, originally it was tailored for classroom type. So whereby we actually allocate quite a number of times for, Q&A and also interactive session. But because we have changed this to the online delivery, so in a way, you notice that most of the time is a one-way communication, is from me to you. So in a way, it's actually shortened quite a fair bit of time. So if I were to follow the timing, you notice that yesterday we probably end at 4 o'clock. Because we do not have the lab, and second thing is actually a one-way communication. Today, if I were to follow through this process and we took out the labs, right? So the session probably may end at somewhere around 2:40 or 3 o'clock. So what I'll do is I'll probably allocate more time by the end of today, let's say around 2:40. Then we see what other question pops up. Then if needed, probably tomorrow I'll add in some of the more detailed presentation. Like for instance, yesterday I do notice that this revised training material to not cover in great details about the RCAC, right? So I have to use a previous presentation tag to cover up those missing components. So along the way, if I do notice that is there anything that is not covered in depth or enough for the training, what I will do is probably I will show a live demo, or I will walk you through a live environment whereby I'll demonstrate those training material in great detail, right? So what happened now is we will start with the unit 10 all the way down to unit 18. So we will continue a little bit of the authorization list top authority, that those question was being asked as well. So then from 10 o'clock onward, we will look at work management. How do you manage the system? How do you configure the system? Until around 1 o'clock, whereby we will end the work management portions. And starting from 1 o'clock onwards, 1:35, we will start with the little bit of the basic CL programming. So we will talk about programming concept, what are the programming tools, and we will do a little bit of intro, what are the interface like PDM, SEU, you can use to do we call simple programming, a CL programming on your AS400. Okay, then tomorrow we will cover more in depth. So basically, this is what we will cover for today. So with this, I hope you can plan your time. I know some of you may need to, get, off the session and go to do some of the things, right? So with this new schedule, right, you can screen capture this screen, and then plan your attendance, right, or various track that you're more interested in, and join the track as and when you need it. Okay. Okay, we will continue with where we left off yesterday. Talk about authorizations or authority. How do you protect and secure a system, right? So the two things that we will cover for this morning session is the authorization list and adopt authority, right? So other than if you recall a little bit of yesterday, we talked about user profile and group profile. So user profile is where you specify every single users, what are their authorizations, what are the things they can do, they cannot do, right? How do you protect your object? So a group profile is where you tie all these user into a group and you specify their authorization in that group manner, right? So what if there is another more complex way whereby you have an object that you allow user A, right, to access certain things, user B to access certain things. So this is where authorization lists come in, where I'll cover in a little bit more detail later on in this following chart. So we'll list the step to secure object with authorization list. And how do you, what is the IBM OS? What is the criteria or hierarchical way that how they authorize the object access, right? So this is continue where we left off yesterday. Okay, so now this is the introduction of authorization list. So this is what it is. The user say, I need to give the same set of authority for multiple object, right? That's easy. Use an authorization list, right? Excuse me. So here you go. You have a object owner called user tree, and you create an authorization list, and you create this user called public exclude, meaning that this object called let's say a file or program, a list of object that you create a list, and they say all the public are not allowed to access this group object or this set object, and user one you can use. Just give me, let me bring up the pointer. Just a minute. Right. So user one, you can only use the list of object. User two, you can have authorized to change. And user four, you have full access all. And user five, you have changed. Right. So this is much complex that which cannot be, if you were to do the group profile, all these users inherit the same thing, you see. So you cannot have variant. But with this way, you base on object list, then you can actually allow this group of users or this set of users to have variant authorizations, right? So how do you do that, right? You can actually go to the iNavigator, IBM Navigator for I, and you go to security again, and there's an option called create authorization list. And in there, you pop up the second window called action, right? And then you select new. And then this is where the new authorization list came out. And you can actually put in the name of the authorization list, right? Let's say you say, okay, this is for payroll authorization objects, right? So public is exclude, example, or use, right? So from there, you can actually, from that authorization list, so the list is already created, authorization list permission, and that's where you can actually enroll your user and permissions, right? To enroll your users, what are the authorization that you wanted to give them, right? So object secure by the authorization list. So basically you can actually list out the list and show what are the objects that you want to cover by this authorization list. So here you enroll the object. The previous one, you enroll the users. Then second one, you can actually enroll the object. So what file you want, IFS folders, and so forth. Okay, this is pretty user friendly. Okay. Again, from here, you can open securing object with authorization list. And this is how another way to do it using the QC library open, right? And you want to open the IFS file, right? And then again, you can set the permission here, right? And from the permission, you notice that in this library, you can also authorize this library with authorization list. Okay, so you can put in the authorization list, you can click on the browse, and then you can select those lists that you created, okay, based on authorization list, right? So what are the considerations for authorization list? So you cannot use to specify authority to a user profile because authority to a user profile, we do it in the user profile way, right? You cannot use to specify authority to an authorization list. Mean you cannot authorize list based on to an authorization list. So basically, authorization list is individual, is standalone, right? So an object can be secured by only one authorization list. So an object can only be specified one. And when you delete the object, the authorization list doesn't affect, right? User list authority apply to all objects secured by that list, right? As long as the list is in place, all this user will be in place. How the authorization will follow the list. A little bit more detail about authorization list and group profile. As you look at the second bottom here, the bottom box here, you notice that these are a group of users that belong to, let's say, a payroll group, right? These are 4 users that belong to the payroll group. And this group specify the usage for use for this file and all for library 23. You can change for the SP05 and so forth. But all of them actually have the same authorization. You cannot have variant authorization. But if you were to look at the authorization list here, right, and these 3 are being authorized in the same authorization list, right? But the 4 user, the 4 user here have different authority. Like Bill can only have the authorization for use. Wayne, all access. Guna only have use access, and Frank change. So this is where the difference. So this gives you a overview or an idea under what circumstances you would use authorization list and under what circumstances you should create a group profile for them, right? So in most of the cases that our customer scenario, we notice that they are mostly being authorized by group profile instead of authorization list. But in certain case, right, there are requirements. That's where authorization lists are in place, whereby you want to protect a group of object, right, especially IFS, that all the users are allowed to access except certain users, right? Operator and all these things, they have the full access backup and all these things are removed. So the rest are only can have the use access and so forth. So these are the way how you manage it. Okay. So then again, this is a comparison. So authorization list can secure multiple objects, right? For the group, it's the same thing. So a user can be on multiple lists, right? So group profile, as you recall, a user can only be a member of up to 16 group, right? And user can have different authority. Now this is a bit different. All users in the group have the same authority, right? And moving down, same authority for different object using it, and different authority for different objects, okay? An object can be secured by only one authorization list, and object can be authorized to many groups. So again, based on this comparison, it actually makes you allow you to make a more easier decision under what circumstances you should use authorization list and under what circumstances you should use a group. Okay. Now this is where how an IBM I OS go through the authority checking, right? So when a user try to access an object, so the first thing is you check this user, let's say Jason, this user here, do I have all object authority? If I yes, then it move on. If I don't have all object authority, then do I have Jason myself user specific authority? If no, then do I have an authorization list? No. Then it will check the next thing, whether Jason's belong to what group profile. Let's say Jason's belong to the let's say payroll group profile, and payroll group profile happen to have all object. Then it grant me to the access here. If no, I go down. Under this group, do I have special authority to this specific object? Again, if no, then I'll go down to this group. Does the group belong to any authorization list, right? If no, then it went down to the object public authority. Do you have a public authority here for this object? Let's say no. Then again, does this object have the public authorization list? And again, if no, then it's all rejected. If any of this part here, yes. So it follow this hierarchical, and you come here, it doesn't have an adequate authority for this object, then it allow grant. Otherwise, this thing will just get rejected and you will get a, if you are not allowed to access certain object, you'll say error. Okay. So we skip this one, there's no exercise for it here. Right. Now, yesterday there was a question posed by a lady about adopt authority, right? So what is adopt authority mean, right? So this is a very unique case. If you're a developer, you probably know this is you hit into this issue time to time. So what happened is actually I do not give access to any one of these object. Example, your payroll master file. But you need to allow an operator to process that. But you do not want the operator to view it. So you cannot have allow operator to have, you cannot grant authority to the user. You cannot grant authority to the group. And you also cannot grant the operator authorization list because you don't want them to have any chance to go in and do anything, right? Entire nothing. But you want them to process it every night. So what they do, there's a way to actually temporarily grant the user authority to access this file, process it. But after the job process finish, the user can actually open that file and view it. So this adopt authority way is actually for processing. But a newer method is called fire call, right? If you were to notice, if someone were to take leave, let's say your security officer, one of them, take leave, then no one can do user administration, right? So what can happen is a backup user or standby users can come in and you elevate his authority just based on one day. Let's say the security officer is on leave for one day. So you can do a fire call. There is a security tools that IBM Lab Services provide called fire call tools that you can elevate that user for certain hours or certain days, and all the activities that person been promoted will be logged and kept. So you can monitor everything that the person do, right? But for operator, this is just temporarily. So what you do is you can actually use this adopt authority features on the IBM I that you can elevate that of users to allow them to finish the job, and then that authority will be automatically removed as and when the job finish running process. Okay. So again, it come through all this on the left hand side. It go through the standard checking list, and does it have adequate authority? If yes, definitely the end user doesn't have any authorities. So it's no. So in this phase, this is where we call, if you notice the pointer that I'm pointing right now, it's called program adopt and adequate authority. If the program can adopt authority, then yes, then this thing can process. Otherwise, it's rejected. So how to do that actually, right? How do you do this? This training material again is not specifying how do you do it. So what I do, just give me a minute. I actually yesterday I go to the IBM as usual. IBM actually have all this how to do thing in our support material. So let me share this part of the support material for you. One second. Okay, so this is where you can see this is the IBM knowledge base support, and you can search for Adopt Authority via your Google. Just put IBM Adopt Authority, and basically it's actually this thing has happened since long time ago. It's not valid. It's not only 7.1, 7.2, 7.3, 7.4. Right? How does Adopt Authority work and all this thing? It gives you all the explanation. Right? As I mentioned, you want to allow your operator to run a process a file, but this file is not authorized for him on either first we call user profile level, on the group profile level, or authorization list level. But you can still allow him to run it by allowing him to do something called adopt authority. So what you do is actually you can do something called a display program. This is a payroll program, and this is the program name is called paylist. So you can see here the program name is paylist, library is pay library, and the owner is Jones, right? Jones. So the program aptitude is RPG. And if you look at this user profile specified user, and user adopt authority is no. Okay. So sorry, you just have to go through that. You notice that user authority in the list in the middle, right in the middle of the screen, it said no, right? So what happens is if anyone were to run this program with no authorization on that file, the program will reject. It will hit in error, not authorized to run. So what you can do, let me scroll down. You can do this way in the CL program. So you can, a developer can put in the CL program for this operator to run the program. He doesn't need to have the authority in his user profile specified in those objects. But in the CL program, you trigger this command called change program, pay library, playlist, user profile owner. And then you change it again, change profile, user adopt authority, yes, right? And the third one, basically what we do most of the time is change program, playlist, user profile owner, user adopt authority, yes. And this happens is when this program is being executed, it will adopt the user profile owner and to run it. So basically, even though that user doesn't have the authority to run to access the programs or files that's needed, it will adopt the original creator owner and it will run based on the owner, right? So this is how it runs it. When this program finish, right, it will return back to the original user profile back, which is the operator, and he will not able to access those files or program again. Okay. So that cover this module called the module 10, adopt authorities and authorization list, right? If you have any question, you can post on the chat there, and then we'll answer it later. So we'll continue now with the next track, which is module 11. Yeah. Okay. So now we will cover, we finish actually the authorizations or protection of the system. So now moving on is actually the second crucial part. How do you manage a system? How a job is being executed inside the IBM I machine? Okay. So of course, you want a job to be run in the most we call optimized level. So there will be a list of checking things to consider related to performance, how the IBM I function, how it entertain a job request, and also we discuss the view of an interactive job from the perspective of a user versus a programmer, right? And list the IBM object that affect performance and job processing. Also the last one is list of object needed for processing work on IBM I. Basically what we do is actually job management or work management. So we will cover the subsystem, we'll cover how a job is being processed and handled in the system. Okay. So this is an overview of IBM I Advanced Application Architecture, right? So it's basically how the memory space and so forth is being handled. There is a IBM Power Hypervisor residing in the memory base level, and then we have the LIC code running that interact with the IBM iOS. So on the higher layer, that's where the user program is running. So the user program will talk to the IBM iOS, and IBM iOS will execute this on the licensed internal code, and then only go down to the hardware level how it's being processed. Okay. And these are the functional. Functional component means how IBM is being IBM I group or handle the naming convention and organize the programs. So we have something called a library. Library is actually how you group all your programs, all your objects, all your files inside there. And from the library, you have your program, and how you execute your program is actually through a job. So every program is actually, when you execute it, you tie to a job, a task, right? So in other operating system, it may call task, but for IBM I, we call a job. So we have something called object management. So you can manage the object via the library, you group them, and how you handle the work is via the programs, right? How you manage them, all these tasks or track work management handle. And then storage management is where we organize our storage. Again, we have database management, and we have the system resource management as well. So this is how we actually manage the system in these 5 categories. So database object management, you probably know. There's an SQL interface. A system resource management is where you work hardware resources. And the storage management is you work the we call the work disk status or work with the disk. Or also in the IFS file system, you can manage that, right? So work management is where you work active job, work system activities. Object management is where you do something called work object PDMs or display object and so forth. Okay, so now we move on to the work management, right? So overview of the work management is principle for IBM work I jobs, right? So you have the how you want to let the job running either on the batch mode or interactive mode or in communication backend mode or in the auto start mode, right? So this is how a job can be submit or being handled. And then the performance characteristic of job, whether this is a high priority job or this is a low priority job, the runtime attribute, how much memory you want to put it, the storage pool assignment, which memory pool you want the job to run on. Let's say a spool, let's say it's a reporting, you probably run on pool number 4 and etc. And then system job running on pool number 1 or and so forth, right? So job performance is a function of the relationship of how the runtime parameters for each of job. So there are parameters that you can set when a job is being submitted, right, under the job descriptions or under the job queue. Okay, and of course, when you enter to the subsystem later, we will elaborate more. We'll show you more how is all the characteristic of the job. And you can also alter a job in initialization from a default, right? So basically, you can do a change job to do that to make it run better. So as usual, this is nothing, we call new. So all these processing job, be it on IBM I or any computing task, right? A job will need to be processed and loaded into memory before the job can be processed properly. So something old school, right? So basically, we have the input, go to the processing, work is performed here, and then you got the output. So if you remember the old days of computer science, garbage in, garbage out, basically it's the input and the output, right? So basically it's input, output, but what we are more focusing on is actually the middle part, the processing portion. We don't care about the input, we don't care about the output, but we care about the job is being performed in the IBM I. Okay, so this is another overview or high level or how a job is being initialized on the IBM I system. So we follow this called numbering sequence, right? So the first thing is a job is being called up. How you do is, let's say you call a program, call, let's say, follow the just now the sample, playlist, payroll or something like that. So you call a program from the playlist library, and whatever a job is being called, it will look at your site, your user profile. Remember, your user profile have something called a job description tie into it. If it doesn't, then it look at the group profile, whether the group profile have a job description tie into it. So this job description will say, is this job an interactive job? If this is an interactive job, it will go into the subsystem or queue inter, right? So in this memory storage, it load to that, and then the queue inter will have a memory pool assigned to it, right? So from here, then this subsystem, let me put on the highlight. So in the subsystem monitor here, and say inside the subsystem queue inter, what is the routing? What are the process or what the classification of this job being processed? Example, my run priority is 20, right? In which memory pool I'm running this job at, right? At pool number 2 and so forth. And what is the time slice for the processor, CPU cycle, right? You know, sometimes when you do a change job, you want the job to run faster, you change it to 5.9 and so forth, right? So this is where this category of classification is being put on, specify here. And then from there, okay, now I have all the detail. The job is being executed at where and how much resources and what are the memory that, you know, available for this job. Then I will execute a command called Q command. And then this is Q command that actually will go to the program and run that program and load the program into the main storage called PROG1, right? And this is how a job is being handled, and all this is in sub-second. It's very fast. So when the users actually do this, all this is in sub-second, and this thing are being put into place in the main memory in the subsystem pool, and the job is being executed, and then an output is being produced. Okay. So basically, you know, performance tuning. What happened is actually, you like something to run in an optimum level, not super fast or super slow, but in the optimum level. So this is always a performance tuning person will always look for optimum performance, but not, you know, this is how a system is being tuned. Of course, under certain criteria, like for us in the lab services, sometimes we need to do something called performance benchmark or performance tuning, right? Whereby we tune a job to run super fast just to meet certain process criteria, right? So for instance, I need to finish my batch job from 8 hours to 4 hours or 8 hours to 2 hours. And this is something we like F1's racing. So we need to tune the system to run as fast as it could so that it meet the customer requirement. So then the system is being tuned differently to run certain tasks differently, right? So that is part of the they call IBM performance tuning process that you can either do it yourself or you can engage us. But on most of the time, IBM I is self-tuning. You probably know the system will automatically self-tune by itself and make every job run optimum in that available resources in that situation, right? So you do not really need to worry about how a system performs in most of the time. Right. Now this is something more complex. What we do with performance, slower, faster. And this is where, just now remember, we have this job description, system value, activity level in your subsystem pool. You know, this is in the subsystem pool. If you work system status, you will see those activity level. Subsystem description, how the subsystem is being run, located in which pool, what's the run priority, classification. All this we will touch on it later on in the subsequent slide, right? How you handle the job queue, how you handle network attribute, pool size, system display, classes, job status, transition, fault rate, the page fault rate, and so forth. Well, this sounds like a lot complex, right? That's why I say I like this part here because IBM I actually always have is, if you notice that in the system value queue, there is an automatic performance adjustment system value, Q performance adjustment, QPFR ADJ, right? So the system will always self-perform and self-adjust, okay? But there is an option that you can set the performance adjustment to 0, meaning you do not want the system to adjust automatically and you want to do everything manual, right? Okay. Return to the work management again. Right, this is how IBM I's handle a job. So basically, when a job come in, IBM I will check all the system value. Example, whether this is under queue performance or does the system is in the automatic adjustment or no, right? As I said, as time go by, some of the time we don't want the system to interfere how a job is being run. You want that particular job or that timing, all those jobs are being manually controlled. So you can go into the system value and change the QPFR ATJ to 0 and send it none, right? And there are certain network attribute and so forth that in the system that you may have communication that you want that to also be considered. So all the system value involve the performance, they will be referred when the job is being started in the system, right? So from the OS perspective, we have system value, we have network attribute that they consider, and come down to subsystem. So subsystem, again, based on your subsystem type that you created, you can actually customize your own subsystem or create your own subsystem. And based on the requirement that you wanted the job to run, right? So example, a queue inter subsystem, later we will talk about it. And you have work entries, you have routing entries, you have pool. Now all this sound, if you're first time new to IBM I, this sound very complex. Don't worry so much. Later we will show you all these things in more detail. So, and how the job thread is being handled, right? A job thread is being handled whether follow the job queue entry and then run in CMDI or QCMDB, right? It's a batch mode or it's an interactive mode and so forth. So again, when a job entry come in, you check your job description, whether this subsystem say which subsystem I want to go in, right? So this thing will compare the job description entry. You can say, I want to go to queue inter, I want to go to queue batch, or I want to go to queue spool, all subject to how you define in the job description. And then a routing entry, which class you want to run in, right? And also, what are the program handler that handle, right? So we will talk about it later. So we will not touch this. Let me continue the next module that we cover in depth. Okay. This is where we go a little bit more in depth on the work management, how the subsystem concepts and how it works. Okay. So in this unit objective, we will talk in great detail about subsystem, how you assign memory to it, and how the memory work with the subsystem, and what are the memory pool, what are the type of memory pool available in the system. You probably know there are 5 types, right? 4 or 5 types. And describe the type of work that you can run in different memory pool. And also explain why different type of memory pool exist, right? And why do we segregate them? And list the command used to display memory pool information. And last one is explain the information display on work with system status. Okay. All right. Now, give me a minute here. This slide is actually challenging because it's just blank here. Okay, so this slide is basically talk about where a work is being processed on the system. So a subsystem is actually a single predefined operating environment, right? Which the system coordinate the workflows. So a subsystem actually coordinate all this workflow, whether it's being run in queue, queue batch, and so forth. And a system can basically, have several subsystems. As we said, you can have a queue batch subsystem, you can have a queue inter subsystem, and all these subsystems manage different resources. And it manages the job, right, or other than the system job, run within the subsystem. So each subsystem can run a unique operation. For instance, one subsystem can be set up to allow you to decide the number of subsystems that what type of work in each subsystem handle. For instance, QCMN. QCMN handle all the communication work, if you were to notice, right? And we used to have something called QSNADS, and it handles all the SNA communication. So this is how a subsystem is being defined, so that where the work is processed on the system are categorized, properly segregated, right? A predefined operating environment, so that you can organize your job more efficiently. Okay, now this further explains what's happening. So whereby we have different environment that each subsystem handle on its own, so that it will not interfere each other. Example, spooling. If you notice, we have a Q spool subsystem. This Q spool subsystem basically handle all the printing process in the back end. So you do not need to worry about a job is not handled, printing is not processed, and so forth. And when you run a batch job, the same thing. The batch job will finish the job at the back end. You do not need to wait for it. You submit a job and let it run. A report will come out. Maybe when it finished, you automatically send to the printer, and the printer will print it. So for the end user, they do not need to worry about waiting for a print process to finish, and then go and start the printer, go and wait for the printing, and so forth. Again, the communication subsystem, the same thing, right? So it will handle all the back-end communication between systems. Examples. If you were to, there are some customer that used to run IBM, we call workflow, IBM I workflow, or content management on demand. So a document can be processed from one system, and then examples. I have a loan application from a branch. When I submit, it will send from the IBM AS400 at the branch to the AS400 at the HQ. And this thing is through wire communication job. And that documents, everything will be sent across. And then from the HQ, when you receive, you'll process it and you notify the approval for the loan approval. And then once the approval approved that documents, that document will have a stamp automatically and send it back to the branch for further processing. So all this is being handled at the back end called the communication job. So we will go down furthermore about the subsystem description parameters and how do you define them, right? So the subsystem can also define automatic, we call auto start job, a workstation entries, a job queue, a communication job, right? So this is basically an overview of how a work entries come in. Okay. How do we do this? Is actually now this may sound a bit complex for beginner. I'll try to explain in a little bit more easy to understand manner, right? So later probably I will show you the system how it works. So we have a subsystem example. I take an examples of just give me a moment, yeah. Let me see whether I can create something more interesting for you. Okay, 1, 2, 3, 4. Okay, I will do a live examples for this one, so that it's easier for you to understand how a subsystem works. So the subsystem we're going to do a demo sample is actually called QInter. If you are a person that use work a lot, active job a lot, you probably notice QInter is a very interesting subsystem. You have Q auto start job workstation entry, job queues, and communication. So how do you create a subsystem? It's actually using this command here. Let me bring down the laser pointer. This command here called create subsystem description, CRT SBSD. So when you create a subsystem description, it pops out a lot of parameters. What you want to name the subsystem. So this is called a subsystem description. What are the memory pool that you want to use? What is the maximum job in this subsystem that you can handle? All right. Normally default is no max. And what are the job queue entry? Job queue entry, if you remember, you can create a job queue, like for instance, queue batch, QInter. Right. Later I will go through this list for you. So you can actually create a job queue entry for this one. If a QInter job queue, you always see that there's a QInter job queue inside there. If a queue batch, you will see a queue batch job queue. And workstation entry, this is where it's very interesting. Why I choose QInter is because you can actually specify, let's say you have 10 workstation in HQ, right? You want this 10 workstation to run on the Q Inter one on its own subsystem and it's on its own memory pool, so that no one can come in and fight the memory with these 10 users. They have all the best performance, best memory, no one can touch. So all you can put in the workstation name, let's say DSP02, DSP03, DSP04. These are fixed names that you fix in every time when a user log in the 5250 with that workstation name, let's say DSP02, that DSP02 will automatically come to subsystem Q Inter 1. It will not go to subsystem Q Inter 3, or other subsystem. It will always come to this pool that's specified by you. I want the workstation to come automatically to this subsystem. Again, auto start job. Auto start job is where there are certain programs that you want it to run before, just like our Q startup. With that subsystem is started, you want this job to start along together with it. And communication entry is the same thing. What are the communication job or tasks that you wanted to pass in? And pre-start job, again, this is the pre-start job, mean before the any job is being handled, there will be a pre-start entry job that you wanted to run. And routing, how this routing is being handled. Okay, let me go down here. Now, this is where we call work entry or workstation entry, right? So the workstation entry can be a workstation name, can be a user profile as well under the job description, right? So then the job queue entries is where you enter a job queue like Q Inter, Q batch I mentioned. A pre-start job as a program, as I mentioned, you want that program to pre-start in that based on job D. Sometimes it can be specified in the job D or you can specify the programming. And again, an auto start job is also a job D or program that you can actually specify that. And communication entry is where you say who can actually, what devices that should be inside here or what job description should be inside here. Now, routing entry is very interesting. Remember just how I said, what are the program that it run, it go to different sequence number. So what happens is if there is a class, if you notice the third column here, there's a class. If the class is Q batch, so it will under the compare variable called QCMDB is running batch, it's being handled by batch job, right? If you have a Q Inter class, it will run by QCMDI, right? And again, the memory pool will go to 1, the memory pool will go to 2. And the program that Q run is actually Q command. Q command is actually the IBM I execution command. All the rest, it will run on the lowest priority in any of the value, and it will be automatically go to batch, and it go to memory pool 1, right? So the class, remember just how we talk about class here? The class in the third value. So the class being specified in the system is, if you are in the class of Q batch, your run priority is always 50. If you're on Q Inter, your run priority is 20, right? So remember just how I said, if I can change a job to make it run faster in the Q batch, the default of time slice that each CPU cycle assigned to this job is 5,000 milliseconds. So if I wanted to have more, I'll give it 59999 milliseconds. Then there will be more time being allocated to the time slice here. Q Inter, they are very little, 2,000 milliseconds only. So the Q Inter job will always go in the system in and out very fast and also execute in a very fast manner. And push no, meaning that this job, does it being removed out of the memory when it reaches this time slice. So for batch job, most of the time, the job will not be pushed out. But for Q Inter, it's in and out. So it's just like touch and go. So a job can get into the system, being processed 2,000 milliseconds, and then it finish, get out. So, and in the queue waiting, the waiting time of the run part of queue batch job is typically slightly longer because the batch job are most of the time running longer time. So when the queue coming in, it will wait for 120 seconds, then it will try again. So when Q Inter is 30 seconds, right? So this is when you start the subsystem Q Inter. So the subsystem will be start and run in that process. I'll do a live demo here. So what happened is you can see all these workstation entries, workstation type, and so forth. So it's basically you can say, okay, I want the workstation type 3180 to come in here, right? All type. So I will go into, let me just re-explain a bit. So workstation name, I have one special workstation name called LWS1. And remember just how I said, you can specify what type of workstation go to which subsystem. So I have a LWS1 come in. It doesn't care what user. So as long as you come in, log into the 5250, you specify that 5250 device as RDBS1, will automatically come to this subsystem called QInter, right? If you, there is another specification that's specified here called workstation type. So all, a strict all means I don't care. So a workstation all like 3180, it will come in here. 3197 also will come in here. So basically in this area, even though you specify LWS1, the remaining will still come in because the workstation type is specified all, right? If you specify none, then only LWS1 will come in, all right? And again, these are the default system configuration, right? So when you start up or IPL the IBM I, there is a system value called Q control subsystem D, right? So when the system ship, when the IBM I machine power up, the Q control subsystem is always set as a value called Q base, right? Q base will only, when you IPL the system, when you start up the system, the Q base will only start this Q spool, and there are only a few subsystems is being started. Q base, Q syswork, and Q user work are all being started in this one. But if you change the, most of the customer now are using set the Q control subsystem to Q control and not Q base. So when you set this to Q control, the auto start job will start Q inter, Q bash, Q spool, Q CMN, and Q server, right? And it also will start the Q syswork and Q user work as well, right? So by default, all this is being started. Okay. Now Q user work and Q syswork are the one that you use for all your JDBC, ODBC connection, right? And those backend job that you're running, right? Q inter, all your 5250 screen. Bash are the one that you run bash job. Spool is where you run all your printing. QCMN is where your communication, your TCP/IP. And Q server is where your file server's job is running here, right? Okay, let me just pause here. I'll bring you to the subsystem. Let me see, I can bring that up. Just give me a second. So you can see my AS400 screen here, right? So what we do is actually, if you work active job here, you'll see that you have all this subsystem in place, right? So you have Q batch, Q CMN, Q control, your web server, QHTTP servers, Q inter, right? And Q server, Q spool, and so forth. Then how do you know, how this job is being defined, right? So what you do is you actually do this command called work subsystem D, and I say all. So this is where you can see all the subsystem. Let me go down to Q inter, whereby we just go through that, right? I do a 5 to display my subsystem. So you can see that this subsystem is called Q inter, and I go with option 1, the attribute of it. So give subsystem. What is the maximum job? Remember just now in the slide, we talk about maximum job in the subsystem. By default, it's no max, meaning that you can allow up to no limit, right? Now this is next one is very interesting. Since you guys are here, but it actually cover in the basic operator training. If you notice that this one called sign on display file, a sign on display file is called QD sign on, QSYS. Now in QInter, whoever come in, you can actually customize your login screen, your front screen, right? So you can change this display file and customize it to your company logo. So that's where when whoever come into this subsystem QInter one, it will use that customized logo, all right? So in pool, this is where you specify the memory pool. If you notice, you go to pool number 1 and number 2, right? Let me show you what is memory pool. Work system status. And we have 5 memory pool here, right? So each of these is representing the memory in megabyte, right? So we have 5 memory pool here, and we can see that if you press F11, I can't do the F11 just a minute. Keypad is different. Pops up. F11. Okay. So you can see that the maximum active job that's set here, right? So basic number 2, even though I say there's no maximum active, the system will self-tune. So the system paging option will do the self-tuning. Calculate means the system do it itself. Fix means you're not allowing to do any self-tuning here, right? So basically, this is how a memory pool is being handled. Let me go back to this one. Okay. Now we continue with option 3, auto start job. So what's the auto start? There's none here. See, meaning that you do not have any auto start job, right? Workstation entry name, the one I mentioned, I told you, if you want to customize who come to where, so you can say there's none. If there's none, you look at number 5, the type. You notice that it will show all workstation, all here, see? All the workstation type, 555 console, all will come to QInter, right? And job queue, you always see this QInter. You have a QInter, and you can have something called a Q System 36 MRT, right? If you are in the System 36 environment, right? And number 7, routing entries is where you compare the class. Remember just how we showed the command 10 is running interactive QCMDI, right? So it start at position number 1. And the remaining, you can customize this thing as well, right? If you're familiar with all these things, then the system match this value, it comes to this value. If you run this, you run in QIGC. If you match the Q system is 36 MRT, then it goes to 36. And also it match the Q system 38 command, it go to this one here, right? We have done the routing entries. Yeah. So we go to communication entries here. So again, there's none because we don't specify anything, right? Remote location name, if we are doing any remote location, there's none, right? Restart job, again, there's none, right? All these have different characteristic based on different, we call subsystem characteristic. So if I were to show you Q batch or QCMN, right, you will notice there are different entries. So the QCM entry, you look at communication entry, right? You can see now in QCMN, I have a lot of communication entries, right? Okay, so this is where all the job is being specified and tailored. So this our job will come to QCMN, right? So if you notice that the workstation entry, they will say none, right? And 6, 4. There will be nothing here to run. Okay. And if you look at the full definition, it go to the base, the system. So in a nutshell, right, this is basically how we define our pool. And there are many communication pool, QInter and QPGMR, QServer, and QSNet, and so forth. And even the Q finance subsystem, they are something old system, right? So most of the time we use QInter, QBatch, QBase, QCMN, right, QControl. Okay. And QServer is very interesting. QServer is where you have all this IFS and so forth. Let me show you the Q entries. Right, the file server entry, and then you have the communication entry, Q server. Right, the pre-start job entry. You see, these are all the pre-start job entries that is actually for IFS and FTP, right? The FTP job and so forth. There's one more. Let me just see. These are the one that handle communication as well. Yeah. So all the TCP/IP stuff requests are all coming here. Notice the QTCP/IP, right? Okay, so now we go back to memory pool, right? So how you assign memory? So memory is being assigned, if you remember just how I show you work system status, whereby our memory is being divided into different memory pool. We have share pool, right? So you can customize this share pool as well. So a memory pool in which multiple subsystems can run jobs, and you can have up to maximum of 64 shared pool in the system. And you can also have private pool. The private pool is whereby you want to run a single subsystem inside and you're not sharing anything with anyone else. So you can assign a fixed size of that and also the activity level when the system is created, right? So in the old days, many customers like to do that, but as and when the IBM I system is getting more faster and more powerful, and memory is getting cheaper, and also we have this high performance SSD, so we tend to fall back to its original 5 pools thing. You do not need to, since everything is sufficient, you do not need to customize it. But in an environment whereby you have limited resources, limited CPU and so forth, and you want certain group of users to run in the most efficient level, not sharing, so you can still consider creating shared pool or private pool for your we call VIP tasks, right? So the shared pool type is equivalent to the machine pool, base pool. You probably notice there are 5 pool there, right? Just now, yeah, machine pool, base pool. These are being run by the DB2 or the OS communication job and so forth. And the interactive pool is where your queue inter is running. Queues pool, SPOL is where your print job. And as we said, the share pool can go 1 to 64, right? This 1 to 60 and plus this 1, 2, 3, 4. So this is where it mentioned up to 64 shared pool, right here, 64 shared pool. And this is what it said, share pool number 1 to 60 plus 1, 2, 3, 4. Okay. Again, why pools? Why we want to have segregation of memory, right? So you see, this is the machine pool, base pool, right? So all this system job is running here. And there are jobs that you do not want them to share. For instance, as I said, there are certain workstation you want them to have VIP. You can create a private tool and all this batch program running. And there are also batch job running, only batch job. So this is where I say use segregation of memory. If you have limited resource, you want every one of them run on a designated performance or designated, we call balance based on your tuning. You can do that, right? But if you have everything is more than sufficient, then basically you can remain at that 5 pool and you do not need to worry about it. The system will sound to you and everything will be fine. But in the event that you have special need, you need certain group of tasks, you want them to be on extremely efficient manner, not sharing, then you define the pool, right? So the machine pool is where you can't touch, the base pool as well. So you can touch the interactive pools and this pool, right? Basically, the first one you cannot touch. The second and third and fourth, you can change it. The task, the job. Basically, remember there's a fixed calculate thing. You can let the system decide for you as well, right? So it's basically segregate the memory in a logical manner, logical areas of main storage job, right? So there are 2 types of pool, private and shared, right? So the system can have to 64 active storage pool. You can have up to 10 defined storage pool. One subsystem can have using different memory pool. You can go to 10 defined memory pool. So the pool size determined based on what you have, actual physical storage, memory storage that you have in the system. So the memory is located in a non-contiguous page, right? It's a non-contiguous, and memory is also reallocated when the no storage parameter is used. So the paging is restricted to individual pool. Because when the pool is full, the page is being paged in and out through the disk, right? By individual, right? It's not shared. So activity level determine the number of job thread in this memory pool. Remember just now in the green screen I show you there is the numbers of job you can set, right? And how do you create a pool? So when you create a subsystem, the subsystem name is called ABC, and you want to use a pool number one, and the memory location, right? And the 3 active tasks, and also you want to use a memory 2 with 200 meg, right, megabyte, and 5 tasks running of it, right? So shared specialize the machine pool, you say machine base, and you can share the general interactive pool 1, shared pool 1 to 64. So again, you can define another one called gray subsystem, define, and you can say full, and you can say, okay, I want to use, the first one is base, second one is interactive, the third one is shared pool 1, right? Then another way of creating subsystem, GHI pool, and I want to use the first one is base, second one is interact, the third one is share pool 1, and the fourth one is actually a private pool, right? 4, and I assign 200 megabyte, right, with 5 active tasks, okay? Okay, this is where you create subsystem queue inter. The queue inter is actually by default a system. You know, all this first character queue is system. IBM's come standard, right? The queue inter pool, right? So you can actually create, if you delete that, you can create it again, right? Create by using this command called create subsystem queue inter pool. I want to use base pool number 1, and base the number 2 is interact, and maximum job no max, okay? So again, you can change the pool size when the system is active. You can change share pool. The pool size is interactive, right? I can change the size to 2001 and activity level is 6, right? So basically you can actually constantly because as and when the system needed to be more optimized or more faster, you need to job to run finish much earlier. You can actually change this, but what typically we do is we work subsystem status, and we do the change there, or we work active job to change the job size or time size of the job, right? But this is, the pool is where we change, you want to change the memory of that pool so that there are more memory coming in into that, right? Based on that maximum server memory that you have, right? It doesn't mean that you change this if your maximum memory already reached the maximum. So what you can do is you have to steal or borrow memory space from other pool, right? You can borrow memory from maybe spool, SPOL, because there's no one printing, right? You can borrow memory from QCMN. There's not many QCMN job running. So this memory can be moved from one memory to another. Okay, I think I went through this just now. Display the subsystem description, right? So this is what happened. The subsystem description called queue inter, right? So when I noticed that your maximum jobs in the subsystem in Nomax, remember just now I mentioned about the queue, the sign-on display file? So you can basically customize the display file if you wish to, right? So I know a lot of customers doing it because that gives you something more, feel home or feel more comfortable. You tie to an organization or tie to your department, or you tie to, if you're a developer, maybe you tie to your own workstation, right? So you have that sense of belonging or that sense of we call customization part. So if in the basic operator task, there is one of the we call a module that we teach you how to do customization. If you are not, don't worry. The IBM Work Management or Info Center do have a lot of material there, a hands-on guide, show you how to do that, right? So the pool definition for queue inter is 1 and 2, base and interact pool. Right, again, you are using this command called work system status, WRKSYS, STS. So over here, remember just how we said we have a number of maximum active job, and these are the memory that you assign. These are all dynamic if it's fixed. These are all dynamic. The memory size will just pool number 1. Remember, pool number 1 is base. Pool number 2 is interactive. Right. Pool number 3 is spool file. Queue number 4 is, if not mistaken, let me check. I remember number 4. Machine base. Okay, never mind. We will look at it later. Right. Yeah, sorry, interact. So queue number 4 is interact. Right. So machine base pool interactive. This is where your queue inter job is running. Okay. So again, you can see that just now I also show you the paging option. Fix means you're not allowing the system to tune it for you. Right. If you have an asterisk CALC, the system will do automatic tuning based on the number of activities there, and then it align this maximum activity job so that the maximum or optimum job is run inside the system. Right. Okay, when you issue the command called work share pool, as is where you can further define your own private pool. Remember the share pool 1 to 6, you can go all the way to 60 plus this 1, 2, 3, 4. So you can create, when you do this command called share pool, basically you're creating another set of memory pool. If you have additional or extra, you can put it here and all these numbers will go down. So it will reduce and whatever you specify here will be fixed. So you fix that memory, and that is where the share pool 1 is being used for whatever new subsystem that you wanted to use, right? So how do you do this on a graphical way or we call a GUI or web browser way? So the IBM Navigator for I, under the work management here, active memory pool, this is actually work system status. And you will see that the 1, 2, 3, 4 is shown here, machine-based interactive, and the 1, 2, 3, 4 pool ID. And the memory pool size in megabyte, and the number of threads running, and also whether there's a purging, a fault rate is happening here. This is exactly the same as your green screen, this part, this screen here, all right? Again, you can go to share pool, meaning this is the same command, work share pool, right? Again, you can define your pool size if you want to, right? All the way to 64, right? 60, sorry. Right. So, and how you change that, again, this is slightly more troublesome in a way, even though the screen is more user friendly, but how you do it is you have to check it, go to properties, then you go in and change it, right? So this is how you change that. It's unlike green screen, you go straight to the tab, all right? Again, performance, right? So you can see the weighting, the fault rate, ineligible, these are all the same view. And again, you can change it. You can go to tuning, you can change the size and so forth, right? All right. Work system status is the same thing. Just now you go to basic work management, now you go to system value, work status, right? Again, it is a different view, but basically it's the same thing. You can see how many active job in that. Okay, the processor and memory. So I find this is as not as how do I say a simple one glance thing like this one. Work system status. This is basically the same view, right? From here to here, this part here, right? So is yeah, this is work system status, right? Right. So you can see that this status storage. This is different. Let me go back here. You can see that this data storage system value and this indicator basically is the same with this part here, the green screen. What system status, if you were to press F6, if I'm not mistaken, you can see that this status, system status, all these are via the command key. All right. So if you're familiar with those key, you can actually straight jump to, if I'm not mistaken, function 6, you jump straight to the this status, right? Whereby in this screen here, you will have this extension, the this status, temporary storage pool, storage system value, and so forth. Basically, it's the same as those commands, right? So basically, that cover the job descriptions and pool. Okay, may I suggest what we do? Hold on. Now we are at 12. Sure. Yep. So we take a 10 minutes break. We just finished from module 10 to module 12. So we take a 10 minutes break. Now it's 11:55, right? So shall we resume at 11:05? We are on time, actually. Cheng, hand over to you. Cheng, are you there? Or
Yes, yes.
Yeah. Shall we take a 10 minutes break so that we
Yep.
resume at 11:05? Yeah.
Yep. We should. Yeah.
All right. So what we're going to study for work management module is how a job is being processed and it's being handled by the IBM I operating system. Yeah. So we're going to focus on how work is being processed and how, is there any difference between a job and a thread, right? Is how it's being viewed and handled by the IBM operating system. And we will also show the type of system and user job that can be run on the system, and also explain how different type of jobs start and end inside the system. And also the module will cover interactive job routing process. And again, the second last is actually how paging work. Paging is a memory. Page work into the subsystem, and also different types of fault that can happen. Right. So basically, this module will give you a brief understanding of how a job is being processed and how you use the memory, and how and under what situation there is a paging happen, and also a page fault happens. Right. So let's begin. So we are looking at job processing right now. So when a job is being processed, this refer back to the previous slide. If you remember, we have subsystem ABC, DF, XYZ, and each subsystem is being, when a job is being fired up, right? If you recall, you go through a process of the job is the 1, 2, 3, 4, 5, 6, 7 steps. If you recall the previous slide, right? So you go through. This is an interactive job, or we call a batch job, and how the memory pool is being assigned and so forth. So each job will have this surrounding step and, and, and stuff inside that, right? So basically, all jobs can be divided by the system jobs and user job, right? So there are system job and there are user jobs. So what are the system jobs about? System job is job like your subsystem monitor, your performance monitoring, your system function, your spool program. And the user jobs are jobs like your 5250 screen interactive job, your batch job, your auto start job, your communication job, and your pre-start job. So the pre-start job can be, a communication. If you have WebSphere and all those JDBC, ODBC, you can actually have those pre-start listener startup based on the number of, based on your workload. Let's say you want 20 pre-start job to handle 200 users. You want 50 job to handle 500 users and so forth. So let's take a look at how different start and action for different job types. So how a job is being initiated, right? For interactive job is very interesting. When you have a sign on, when you have a password go in, then this job is being started. And how it ends, when you have a sign off, this is job is being end. Then the job is officially out of the system. So for batch job, so when the job is being released from a job queue, let's say for instance queue batch, and you get into the subsystem called queue batch, is being processed. And when the job finish running, then that's where the end of the batch job. And auto start job will always, when you start the subsystem, right, the auto start job will start and run certain process. And when you finish the program, then this job is ended, right? Communication job is a listener job. So when there's a request, there's always listening to remote requests. So when there's a remote request come in, the job will start process. And after, let's say for instance, a TCP/IP handshake, right? So after the handshake, authenticate and being done, then the program ends. So this is where the authentication, sorry. Give me a minute. I try to bring up the laser pointer. My mistake, sorry. So a communication job will end in that way. Now, what is a pre-start job? When the subsystem start, the subsystem start. For instance, you want to pre-start 20 listener for GDBC or DBC. So when you start the subsystem, you can say, please bring up 20 listener job, right? So when this listener jobs finish, then when you end the subsystem, this 20 job will always reside in the subsystem until you end the subsystem. Then this job will end, right? Spooling is quite similar to batch join. When a spool file or out queue being submitted to the spool file, that's where it starts the spooling job. And when the printing or writer command finish, right, that's where the spooling job end, right? So unprinted spool files for the job that have ended are still managed by the system. So if you have a spool file that have a safe yes, so this is called unprinted spool file. So there will be still reside in the system considered as a job. So that's the reason why, when you work out queue or your operator from time to time, they need to clean up the spool file because that is still considered an active job in the system and it reside in the memory pool, right? So interactive job, user view. So basically, when we talk about it, interactive job is where a user sign on and sign off. So when the user sign on, that menu or screen will pop up, right? So the user could probably accessing a database, printing a report, and so forth. So basically, the program may touch the database file and generate a reports, right? So this is the interactive job, how we run. So let's go into detail. So the screen, right? So you may run a called report screen, say key in parameter. I want to print report from date 1st of October to 30th of October. So there is an input parameter screen. And this input parameter screen is actually being brought up by the program one. So you call program one, right? So program one will say, will show the screen. If is the parameter input 1st of October to 30th of October. I want to print out all the monthly payroll program. So then this program two will go and run the report program, which generate a print file. And this is where it access the database and also it print the payslip and so forth. And the payslip, after the print file is being generated, you go to the print out queue, what we call it output queue, right? So this is an overview of how an interactive job is being run in a common manner, in the most typical manner. Right. So again, it go back to the previous frame before when we talk about. Let's try to make this minimized. The first thing, you remember last time we had this 1, 2, 3, 4 thing in the previous two slide. So a workstation user enter the user and password, and you will bring in the job depend on the user profile initial program, right? You will call up the first screen and you call the program, right? And based on the job description and so forth. So if this user is able to submit a job, so process the payroll. So the payroll process will being submitted and run in based on the job queue. If the job queue say submit to a queue batch, so that job will be submitted and handled by the subsystem queue batch and being go into a job queue, right? So when you start the subsystem, of course, most of the subsystem has been started earlier, but just in case the subsystem is not being started, then the job will reside in the job queue and waiting for the subsystem to be started. So when the subsystem start queue batch subsystem is started, right? Queue batch will check, is there any job queue entry? Oh yeah, there is a queue batch job queue inside this subsystem. Then is there any job in the subsystem that is, and the job status is released and not whole? Then the subsystem being brought up, well, start running the program, the processor program, right? And okay, let me see number 4. Is there anything I miss out? Okay. Number 4 is referred to the system A and system B. There are two different systems. Is there any communication between A and B? So you can actually, for IBM it's very interesting. You can actually request data from another system using DDM file or using submit job, right? And return a data, right? So if number 4, you can actually submit a job from system A to system B under the QCMN job, right? This job will also be fired. Also, the other way is QSNAP, right? SNA, APPC, APPN type of programming. So you can actually wire the QSNAP subsystem. Data can be being bring in from system A to system B, or a job can be fired from system A to system B as well, right? So this is various type of job that is being happen in the IBM. Of course, others like I mentioned, the JDBC, ODBC, submit remote command, AIX job. So those are the jobs that can also be fired up. So some job can be as a job, some can be a program, some can be a thread. We'll touch about that later on. Right. Now we will touch about top interactive job and how do we tune it, right? Again, we go back to the subsystem, QInter, right? So any job that run inside the seal system, QInter, right? You notice that it's actually being processed by this command called QCMD. QCMD is where it's actually a command line, right? A command line that under, if you were to go into the system, you type QCMD, you actually bring command line. Let me just show you that. Give me a second. I'll bring you to the 5250 screen. Okay. So you can see my 5250 screen here. If I call QCMD, right? This is the QCMD, command line entry, right? Let me just go back home again. So if I do a QCMD, right? This is where it is, command line entry. Okay. So let me switch it back. Okay. So when the job is being entered in the queue subsystem, QInter subsystem, right? So if there is all the job is actually being brought into a queue command line interactive process, right? So that you can actually execute call and so forth. Okay. Again, it depends on your subsystem description and definition. So what it means is your subsystem QInter will use the memory pool for 1 and 2, right? The memory pool, storage pool, using 1 and 2. And the QInter have no maximum job defined, meaning that you have 2,000, 3,000, 10,000, all this job can flow into queue system, right? QInter subsystem. Again, just now we mentioned about this, if you have workstation job description entered, then it will restrict LWS1, right? And basically, this is how a subsystem we call QInter manage the job request. So if a job come in, of course, remember you have your user profile has a job description specified there, right? What is your user library list? What's a user job description? A user job queue, your output priority. Sorry, I'm actually referring to the right hand side. Your username, your job queue, your output priority, your routing data, right? Which is here, right? And your run priority. Anyone still remember a job system class? QInters belong to run priority 20, right? And you have the 200 millisecond running, right? So that is where a subsystem is being managed. So selecting the initial program. If you remember the user profile, right? Your profile program will have the initial program or initial menu. So if the user is either one, right? And the job description in the user profile title, it can be a group job description or it can be an individual job description, right? So initial program or initial menu will bring you to the menu. The job description will tell you which subsystem when you submit a job or when you run a job it belongs to, all right? So basically, this is how a system assign which subsystem to handle or process your job entry. Okay, work management interactive. Interactive user may not all use the same application. Yes, not all the users using the same application, and some user may require page protection for faster service. Examples: a telephone sales, a customer representative, a face-to-face customer. Basically, what it means is they need a faster response time of the 5250. Now, nowadays things have changed a lot. This sample can be further elaborate, like your web browsers, your internal web portal, internal. Will require a faster response time versus the other application. So in banking, you have many channels. You may have kiosks, you may have self-service kiosks, and you may have mobile banking, you may have all these things, and all these things will require a faster response time compared to others. So that's where this system will be tuned differently, but we need a different subsystem to handle this such job request. So basically what we do is we will do separate pools to protect the page, meaning we give them more memory that you needed based on its requirement. We call a workload requirement, and provide better performance for the important user job. Those are the VIP job, right? So in the old days, we have interactive users. In the modern days, we have these portal users, or we have these mobile banking users, or self-service users that they are being separated. They are no longer in the QInter pools. You probably notice they are in a different pool, like the WebSphere pool or their web portal pools, right? So work management and cyber security function can be used to provide different pools to different users. So each pool, based on their load, right? Let's say your portal will have 2,000 users at the peak period, right? So you will have enough memory for each job. Let's say each job you need maybe 2 kilobyte of memory at one time. So based on 2,000, you have to multiply that and you have to calculate the memory pool size required for that job, right? So each storage pool holds information needed for the job. So as long as the pool has enough memory and enough job, let's say at the peak period of 2,000 job at a one time, then you will have less page fault, right? You do not need page in and page out because all these informations are inside the memory pool. So information needed by one or more jobs that are not in the main memory can be read to the main storage. So if the job requested the page wait for the operation to complete before continuing the operation, is called synchronous IO. So basically, what happened is there are jobs that require a wait and basically, like for instance, you read SQL data from the database, right? So and that information is we call asynchronous synchronous IO, whereby you select extract immediate or something like that. That you need the information to be come in instantly and you do not wait. So the job will wait for that. So until it finish, then it process. So most synchronous IO operation are called page fault because it has to wait for the data from the disk to page into a memory and process and then finish the task. So by using the work with system status display, you will on the IBM I navigator screen, you can observe this information. So this can be if you want to see all these things, you can simulate your own internal stress test or benchmark. There are many stress test tools available, free, online, on the internet. They can download and simulate those things. And then you start work system status. You can see how those page faults happen in your system, right? That will give you a proper, just now there was a question, how do I know I ran out of memory? How do I know I do not have enough memory, right? So by work system status and by looking at the IBM I performance tools, you can actually have a good view of it. We will touch all this a little bit of this later, right? So pool benefit. You can control the work done in the subsystem by controlling the number. Remember when we work system status, there are numbers, active numbers, right? And the size of the pool. The size of the pool is the memory pool. The greater the pool size, the more work it can be done because you have more memory, there are more job can be go in. So as I mentioned, it's correlated. How many jobs inside and each job take up how many byte of memory, and you multiply that number of jobs, that is actually the memory pool size that you need, right? Shared storage pool allow the system to distribute storage requirement, right? So you can have multiple storage pool, right? So on top of 1 and 2, you say I want to use my shared storage pool for interact job that when it ran out, I can have another pool that I can use across multiple subsystems and still allowing them to run in the same storage pool, right? So multiple pool can separate the amount of work done and influence the response time. As I mentioned, this is more granular, more fine-tuned. So in the old days, we tend to do that. You can still do that if you want to find or control a more granular control of individual tasks. As I said, the lazy man approach for most of us, including myself, is we will add more memory and we will still reside in that pool 1, 2, 3, 4. But if you really have something we call VIP, you really need a pool for specials, very, very special requirement. Then a share pool is a way to introduce so that you can segregate the subsystems and you can have additional storage for that pool of users. Okay. And this, we talk about paging now. Yes. So how the system move the object, and the system move what it needs and think it will need into memory. So this is called active fetching or smart fetching. You're probably aware that one thing that Mr. Lee didn't talk about IBM DB2 Excuse me. A lot of time IBM didn't do a lot of marketing talk, especially when it comes to mainframe and IBM I or AS400. There's a lot of technology that is being introduced and not happen in anywhere. For instance, if you ever heard of something called in-memory database, right? So IBM I is one of the platform that have in-memory database, right? For other database like DB2, LUW, Linux, Unix, Windows, there's no such thing in-memory database. What it means is all the database needed, the system will do active fetching. We know what data it needs, right? It will fetch that level of data into a memory so that the system can process this faster in a more effective manner. So it's called predictive fetching. And these are all never explained or I never have any, detailed explanation unless you attend our TechU or the IBM I user group, whereby a database topic has, is specifically in place to explain how IBM DB2 will work versus other database. Then you probably know the big difference there. Otherwise, this remain as a hidden secret for IBM I users. Okay, so again, coming back to here. So most of the conventional OS, what it does is actually it will fetch the data from the disk into memory and then it process. So this is how it happened. This is the disk storage and this is the memory. If you remember, IBM I is single level storage, right? So basically the disk and the memory for the database and everything is considered one piece. There's no something called disk and memory, right? So everything is pre-fetched based on a smart algorithm. So whatever in this memory is not there, only the IBM I will go to the physical disk and fetch it. So when this data is being put back, whatever data I'm not needed, right, I will put back to the disk and I'll patch in new one. And this is what we call paging, right? So this is called process access group page, right? So this is things that being paged in and out. So how objects are stored on this, right? If you follow IBM I, we are following the single level storage. Everything is flat. So we do not know the data. The data can be fragmented into either in the disk or in the memory, right? So objects are not stored contiguously on disk, right? An object can be everywhere. So when the system needs an object or part of an object, it may have to read from multiple disks, right? Because of the single level storage. And the good thing about it is, if you have one disk, just like you have one store, you only have one store hand, and you have a large file, right? So you have a contention because you only rely on one single disk and one single store hand to retrieve the data. But if IBM I talk about many disks. The more disks you have, the better the performance. So that's the reason why we encourage you to have more disks, because if you have more disks, there are more data is being segregated to all these disks, and there are more store hand to retrieve this piece of data. So instead of one disk, you have 10 disks and you have 10 store hand retrieve this A information from 10 disks concurrently, simultaneously. So this data is being fetched almost the same time, all fetched into the memory. Right, so this is where IBM I single level storage different from other operating systems, others, database, because we are implementing data in this way. We are implementing how we store data in this way, right? So internal pointer logically link them together, and it treated this whole thing as one database or one hard disk. It didn't treat all these three disks as three disks, but it treated them as one single hard disk. Right, this is what we call single level storage. Right. So how do fault affect performance? So of course, if you recall, some of you are actually old IBM users. We used to have a very famous IBM architect called Ponima. He always like to use this word. The data stored in your pockets and the data stored, the data stored in your friend's pocket next to you, right? So the closest to you is always faster. So the data stored in the memory is your pocket. The data stored in your friend's pocket is in the disk, right? So whatever, every time you need to get the data from your own pocket is faster. Every time you get the data from your friend pocket is from the disk. Is you need to reach out your hand and pull it out. So this is where there are more fault. So the more disk IOs, there will be more fault, right? So basically, how it causes the cause it longer response time because you need to go to further places to get the data, right? And the more fault you get. So data page fault occur when the following are needed but are not in memory. So except let's go back to what we talked. The database data, right? Non-database fault, access path. The database is not organized properly, right? So data have to be searched on a disk rather than in memory because if you have access path, which is your logical file or your view or indexes in the modern way, right? So data can be organized in called pointer. So data can be searched much faster, right? Non-database fault are the programs. The program code is not inside the memory, right? So it's stored somewhere in the disk, then the program code has to be fetched into the memory, right? Job information, a data queue, some of the data in the data queue is not being processed here, right? So you have to wait for the data queue to send in this data. Okay, so again, when you work system status, right, active memory pools, you see here there are four base memory pool, and we have machine-based, interactive, and spool, right? And the memory size in megabyte, right? And these are the thread, or we call active threads, is being run, right? And also the maximum thread and so forth, and the page fault. If you see a page fault very minimum, or there are some guidelines on that. I'll show you the web page later on. That how do you know whether you need more memory or the memory is not sufficient? Okay. So again, this is talk about paging. So job 1 need 9 pages. You need to page 9 times, right? So job 2 need 11 pages. Job 3 need 10 pages. So we know there are not enough pages for job 3 to be contained in memory because this memory file is fixed. So and then these are being filled up. So you can see J1 is 9 pages being filled up, J2 11 pages, and J3 is not there. So probably J3 can only do 1, 2, 3, 4. There are still 6 not there, right? So what happened is this thing will have to wait for job 2 finish or the time slice end. The data will be pushed back to this. And then it free up the space and allow job 3 to fill up this fixed memory. And this is what we call paging. That data is being pushed out from the memory to the disk and load in from the disk to the memory. Okay. So paging of interactive job. This is we're going to discuss this in more detail, right? So we all know interactive job is very I/O intensive. That's why in the good old days, the sizing, right? We look at 5250 job, but I guess today nowadays there are lesser and lesser 5250 job in the organization. Right? Most of you are using the GUI interface, right? So in the previous time, 5250s are very I/O intensive. So you need a lot of I/Os this to have a good response time. So that's why we will encourage more CPU, more memory and more disk arm to get a good 5250 response time, right? How do we ensure the system have enough memory, right? Go, right? Again, we say if you do not need to have a lot of, if you notice the work system status, you do not have a lot of page rate, and that is a rule of thumb. So for every processor, every memory that you have, there is a rule of thumb to how to calculate. I'll show the guideline. So the goal is to have enough memory so that once the job is being bring to the page, you have sufficient memory and you do not need to page them, right? And it's not shared or stolen by another job. So either increase the amount of memory in the pool or reduce the number of jobs competing for it in work system status, right? So pool activity level, the pool activity level is the job, right? The number of threads that can be active in that fixed amount of memory at any one time. It's the same thing that what we explained earlier. So if you have memory and each one take up certain byte of the memory area, right? So if this memory area, a fixed memory pool has filled up, then the remaining will have to be in the queue to wait for things to free up and being loaded to the disk and push in again. Okay. So again, if you put in too many jobs in the job queue, sorry, don't go back here. So there will be a lot of job in the queue that also take up memory because the memory have to keep this job active in the memory, right? So there are more jobs coming in, right? So whether you see activity level is full or no. If no, then in the level and we call ineligible queue, right? And if no, then this thing is being processed. Okay. Coming back to here, how do you build it and how do you see it, right? So here you can see the job have we look at pool number 2. In pool number 2, you have about 6,000 meg, 6 gig of close to 6 gig of data memory, and you have 146 maximum active jobs running here. You look at the fault, the database fault and non-database fault is 0. This is beautiful. It's very nice, right? And if you look at the system job here, total job in the system is 245. So you add up here, it's probably about, it's not the same, right? But these are the job that's called reactive job, right? Okay, so this is a perfect situation whereby your job is running smoothly and that you have no database fault and no non-database fault, right? So the system have 190 gig of hard disk here, right? Okay, let's skip this part. Okay. So we will follow on with this one. We talk about how it's being processed and what is the function provided, maximum activity attribute in the job queue and max priority in job queue, right? And also how a batch job routing process and the time slice and run priority. Okay. So now we are looking at batch job now. So again, this is similar to what you look at in the queue inter batch job. The system uses, instead of one pool, if you notice that queue inter uses 1 and 2, but queue batch just uses 1, just using 1, which is base pool, all right? So the memory in base pool is where it actually affects how a queue batch is being run. Bear in mind the queue base, this base pool is also used by the operating system and database and all other system job as well, right? So here, this is how a job queue selection, right? So you may have a, this is specifically focused on queue batch subsystem. So I may have a job queue called queue batch or queue batch, job queue A, job queue B, job queue C. So in the job queue itself, when you create a job queue, you know that you can actually specify the maximum job numbers. Not sure anyone has tried that. So we can actually do that later on. So what happens is you can create a job queue, say I have a job queue maximum job of, if you look at job queue B, I have a maximum, I can have 2 maximum job running here. Sorry, let me just bring up the pointer. So I have a job queue A, B, C here, right? I have sequence number 10, 20, 30. So maximum active is no max. I can only have 1 job running at this queue, and job queue B, I can have 1 job running, and job queue C, I have 1 job coming. And maximum priority, I all set to no max, right? So what happened is you have job 2 and job 1 here. You can run 10 jobs. So these 2 will be processed concurrently. In job queue B, your maximum active is only 1. So you have job 4 and 3 here. Then the job 3 will be processed because only 1 job is running. And in job queue C, you have 1 job specified active and you have job 5. So this job 5 is being handled, right? So all this A, B, C can all tie into a subsystem called subsystem queue batch. And the queue batch will have an enabling time running these 2 jobs and this 1 job. So the subsystem queue batch at any one time will have 4 jobs because 1 job 5, 1 job 3, and 1 and 2 running at that time, right? So I'll show you later. So how your jobs how you submit a job to a queue batch subsystem. So you issue this command called submit job. So submit job, and this command call PRP process. This is actually called a program, and it will go through this routing data log CUCMD batch, right? A job name, you can put in a job name called pay, I mean a payroll process, and you want to run it under the job queue called queue batch, right? So once the job queue pick up this one, and your job queue is tied to a subsystem called queue batch, right? There is a job queue entry called queue batch. How I know? You have this job queue in this subsystem description have the job queue by the name of queue batch. And what is the maximum active that you can run? I mean, how many jobs can run concurrently in this job queue? This job queue can submit how many jobs concurrently? It's only one. All right. So the maximum priority is no max, but at any one time, you can only submit one job. Right. When the job is being submitted, how it's being processed, you use this queue command here, and this queue command will call this program called call process, which is specified here. I want to run this program, and there is a job that's being processed here. And of course, the job message queue and noticing is all from the job definition or the user profile definition. So by default, batch jobs are submitted to the queue batch job queue, and again, it can be different. If you have your own customer, you can specify this under here, under job queue here, right? But default is all job queue batch. So the queue batch job will run in the base memory pool, right? So the base memory pool, as I mentioned, has a lot of different jobs running there. You have the server job, routers, your monitors job are all running there. It's some of the system job there. So batch job are set at the lowest priority in base, right? The slime end job may take the situation worse because the slime job is set at 5,000. Remember, right? So time slide indicate the amount of uninterrupted CPU time being allocated in the job, so you can use during a single turn in activities. So jobs are interrupted by only long wait, right? So time size we set that input. So that's why for some of the time, excuse me, we kind of want to set certain batch job to run faster. What we do is we go and change the job, go to work active job, change job, and change the time slide to something bigger, from 5,000 maybe to 9,000, so that this thing run faster. Okay. So if the time slide is exceeded and the job with the same priority is waiting, the system will interrupt the job, right? Remove the job from the memory. This is where the paging come in, right? So in addition, more frequent interrupt call, internal time slice will interrupt the job, right? And it may not be removed. Remember that's how by default, the queue batch job have a purge no in the job description. So that actually will interrupt the call interval. So batch job usually exceeded the time slide because if you're running a long running end of day, right? Normally you will see that it will exceed the time slide many times. While interrupt job do not exceed very often. So default time time is 5 seconds for batch job, right? This is the 5,000 thing, and 2 seconds for interrupt job. Remember the 5,200, and this is where the thing. So run priority is used to determine in order which job are being chosen to use the processor. So for interactive job, run priority is normally 20, and run priority for batch job is 50. Right? So if there are two jobs running here, the CPU will run the 20 one first, consider all those 20 as the first priority, then only you process the run priority of 50. Right? So the system determines which job use the processor by either two methods, the fixed priority or dynamic priority. Okay? So when available, the system will try to assign a job to use the processor. This is a function called task dispatching. So all tasks are being put into something called a task dispatching queue, and this queue will actually dispatch based on the CPU free slot. There are three general type of batch job. We call it a production batch job by the operator. Right, this is normally run in queue batch. A programming batch job both by the programmer. So when the programmer compile a program, right, the same thing by default, it will send into the programmer job queue, which is also tied a link up to the queue batch, and it will compile in the queue batch subsystem, right? Then user's job that submit, like for instance, running a report, right? So user batch job submit by the production users. So they are typically these three type of users will normally use the backend batch job, right? Running this different style of job in the same storage pool may not work well. Yeah, So that's the reason why we create different subsystems for different group of users, right? Running different batch data in different storage pool, so it protect that memory and it reduces the I/O and also improves the runtime. So this is what we say. In a certain environment, you do not have, in the old days especially, whereby memory are very expensive, hard disks are expensive. So we tend to buy the system is just nice environment. So as and when the system have spike or special environment, that's where a lot of time we need to come in and manage the system. But in modern days, hardware is so cheap. So these things kind of not really necessary, but you do face it occasionally under certain scenario whereby you have a system more than 3 years or your system workload has changed, your work style. Like for instance, now COVID-19, a lot of company change from the we call the branch entry to customer self-service. So a lot of things, the job functions has changed. So then you will have to face a challenging response time from your mobile kiosk, your mobile apps users and things like that, because this type of users typically when before COVID-19, they probably have 200 users, but suddenly during COVID-19 or now, you may have more than 2,000 users at one time. So this change of behavior of the load may need you to go into the system and tune it based on different run priority. Right, queues full subsystem. Queues full subsystem is the one that we normally very less because most of the time nowadays we actually you know it uses very little we call CPU resources, and normally the printers nowadays are very fast, so we hardly have issues with queue spool. But in the old days, I'm not sure many of them. I myself, when I was in college, I was actually a system operator, whereby we still have line printer. Any days we have the challenge of printing, at least 3 or 5 carton boxes of reports, right? The few thousand pages every night that we need to print and then send into the pigeonhole and segregate this report to different departments and so forth. So in the old days, queue spool subsystem is where at night after the batch run finished, all these reports are being printed out and generated and sent to the the physical hard copy is being printed. So that time spool are one of the important area that we need to monitor. But I doubt anyone now still print it, right? You probably send your spool file in email or dispatch it to the users. But anyway, for front end users, they still need to print out the physical hard copy of receipt and so forth. But it costs 1 or 2 pages or less than 10 pages. So basically, you do not need to tune much over here. Right, but anyway, we still look at it now. So the subsystem queue spool uses 2 memory pool, base and spool, right? As I mentioned, when come to performance issue, when come to memory page out, typically because as I said, most of the customers uses very little spool. What we do is we will move the memory from the spool, from this spool storage pool, memory pool, to queue inter or QR to others memory pool. This is the first thing that we will move most of the time, because we look at it, no active job. Then you can release this memory, and then sometimes I even end the subsystem queue spool to free up this memory to let the storage being assigned to other pools, right? So again, we look at the auto start job, right? Auto start job I mentioned is where you wanted to start the job automatically inside when you start the subsystem, right? If you ever look at queue control, there is a subsystem called queue control. In that subsystem, there is actually an auto start job that check your system value, queue startup, PGM, and they will read that program. If there is any startup scripting there, when you start the subsystem queue control, this job will go and refer to the system value and call that program or the CL script. And then that is where this startup program will run. Let me see whether I can show you that. Let me pause here. Okay, so let's look at this. Yeah. Remember just how I mentioned to you the queue control? Queue control, when you set up this subsystem queue control, you will have this auto start job entry called queue startup job D. And this is have as shipping have a job description called queue startup job D. And this queue startup job D actually tied to this job queue here, number 6. Right. Let me check that. Number 3. Auto start. Queue startup job D Q6. Let me display that. Let me create queue startup JD. Okay. So where does it go to? The job queue batch, right? So this queue startup job here actually submit the job to run the startup program in queue batch. Okay. So this is how I know. So when this startup program run in number 3, you call this startup job, and this startup job will go and submit the queue startup job in queue batch. Okay. Okay. So this is what we explained. So there is an auto start job entries, and you can specify what you need to start up, and the subsystem start up what program to call, right? Now communication job, and communication job is where we normally look at QCMN, right? A QCMN is where you have all this, as I mentioned, the TCP/IP stuff running there. Your communication task is running, and it uses the memory pool called base. And in most of the time, I would say 99% of the time, you will hardly have any performance issue in QCMN, right? So the memory that assigned most of the time are sufficient, but in certain event, you will see the QCMN uses a lot of memory, is whereby you have some huge communication job running. But the handler, like for instance, the FTP process, is actually not being handled here in QCMN. It's handled in another subsystem called Q user work or QSys work, right? So later we'll take a look at it. Right. So this is just a little bit touch on the communication job. Pre-start job. Pre-start job is very interesting. This only applicable if you have a lot of the we call front-end channels in the banking or insurance, whereby or even if you're using a web sphere, right? So this pre-start job will handle this type of we call remote access to the system via SQL or called remote command call. So let's see what are the pre-start job entry in queue batch. I doubt there is many, but in the queue start job in queue system work and queue user, we will show you later. You'll see there's a lot. Let me just go through that with you. Let me pause here and I share with you again. Let me share with you the other one. If you look at queue syswork of system, they will normally have a lot of pre-start job here. And each one of them actually have, just give me a minute, I jump to another one. if you look at Q user work, if you have a lot of this JDBC client access, SQL running on this, we call the front end GUI. That's where it uses QZDA SONAT or QZDA SSINAT. So this restart job here, you can check, do a 5 to show you. And number of restart job 1, threshold is 2. You see the number of job that it can run here, and number of users. The number of jobs is no max, and number of users 200 times. Every 200 times, then the job will end by itself. So these are the restart job that we run. Let me show you. Okay. So excuse me. So the initial job is 1. A lot of time, if you have all those WebSphere or front end channel, normally we will not set the initial job of 1. We will change it to 20 or 25. So that will allow you to have more pre-start job waiting and standing to on standby. Okay. Okay. So that is more about the pre-start job that we typically set on the system, right? Too little pre-start job, the system will have a high overhead, right? So, sorry, I actually flipping through the slide. Sorry. So that is the end of this module. Before we actually give me a second. Yeah. So let me just bring this slide up. So we just completed a module 14, right? So the time now is 12:10, right? So we are on schedule, on track. We just cover module unit 13 and 14, and now we just on time on 12:10. Yeah, we should be taking a lunch break, right? So again, over to CBS. Probably you may want to announce how long is the lunch break. Then we can resume the module 15 for work management, right? Then we will take another short break. Then that's where we cover all the work management module, and we will take up some question. Then we will continue later with the CL programming. Yeah. Over to you, Ching Pan Sing.
Thank you, Jason. Now it's almost 12:15. So we will start at 1:20 so that we can finish it earlier later, so that the rest of people can go back to do all their work. So we have a 1-hour lunch. So we come back at 1:20. Thanks.
Okay. Subsequently, we're going to continue with the Unit 15, Work Management. How do we submit and track a batch job, right? And after that, this is a very short class, which is a short module, which is about 20 minutes. Then we will continue with the CL programming. We will not take a break because it's such a short time. So we'll continue the rest of the module, right? And hopefully I can do some live demo for you and go through some of the post we call the module with the actual implementation. Right. Let's continue. All right. So I hope everyone can see the screen. Okay. So the objective of this module is actually to know what command is to use to submit a job. Basically, it's the command submit job, and we will go through the we call the backend process on how system submit when the submit job is run, how the system is handling it, and also we will learn how to schedule a batch job. Right, so you can schedule a batch job to run as and when you need it. And let's say, for instance, a backup job, right? You can schedule it to run at 7 o'clock or something like that. And also, we'll list explain the command you can use to track your batch job and how data management intercept output generated by a program. And also explain the function of a printer, right? Print device file. And also, we will look at the process of used by the program to determine where to send your output, right? You can actually send, after a batch job is being sent, processed, you can actually tailor your report output to which printer or which output queue, right? So, as explained, the command to send a job to run at the back end, we call a batch job, is this command called submit job, right? So a submit job has certain parameters that you can actually customize or put in so that you can properly control how your backend job process. So the first thing is submit job. There is a parameter command, your command to run. Let's say, for instance, call program or call report program, and they are parameters that in the submit job. Okay, I'll go through this later on. Basically, they are. Let me just bring up the laser pointer. Right. So the out queue that you can specify your system libraries, your current library, initial libraries, schedule time, schedule date, and country ID and CCS ID. These are we call the job language code. Right. So when you submit based on current or you submit based on job description. So if you submit based on job description, the job will have a job name. You can specify the job queue, the job priority, output priority, whether you want to log the process and log CL program is either yes or no. And also inquiry message reply. If there is any message happen in the process, you can send to which message queue. And the status of hold, the date, and switch, and jobs message queue maximum, and so forth, right? So there are other default as well that say, for instance, job description based on user profile, routing data, the routing data based on the QCMB batch, right? Request data, command, and so forth, right? So we will move on, and this is a little bit more detailed and how a queue batch subsystem handle a submit job. So as mentioned just now, when you submit a job, you can trigger a command QCMB, right? Because QCMDB that trigger this command here. So this is where you can call up a program. So this is where your program name are, your library list and your program name. And you can specify the name of this job. It can be ABCD, it can be night job, it can be anything that you can put in is a 10-digit character, right? And you can submit to which job queue the process is 1, 2. So in this case, you're submitting to queue batch. And this is by default QCMDB, so you can actually skip this one. Right, so basically, when you submit a job, you can actually specify a call program, a job name, and a job queue. Right, the rest is you can take the default, and the system will process this and submit and run in the subsystem called queue batch. Okay. Job message queue, and this is where you want to monitor a job whether it has been successfully run, or is there any message or it end abnormally. So when you submit a job, right, it will have something called diagnostic message, a program terminate message, and a command message. So when the system finish running, the job will have a job message being sent to the message queue, right? Same as your job name. So how do you check that later? We will talk about it. Basically, there's a command called work submit job. Work submit job will show you the job status. Okay. Now, there are two ways to schedule a batch job. So you can do this called submit job, with the parameters schedule date and schedule time. So when you do this, the job is being submitted in the queue and it actually has a time and date that you specify. Another way to do it is actually via we call a job scheduler. So in IBM I, a job scheduler come default or free. So I'm not sure whether you have used it. So you can actually use this work job schedule entry, this command here. So you can work job schedule entry and you will see this screen here. And they are, at this moment, the sample show you about 5 jobs here. So let me go through that and just give you a little bit of explanation. So let's look at this bottom one, QS9UAK. The status is a scheduled job. So what happened is scheduled to run on every Sunday at 3 a.m. in the morning, 3:01 in the morning. And it run on weekly, means every once in a week, right? So the next coming up is actually, it will run on this February 16, year 2020, right? So this is how, if you put a file here, you will see the detail of what program it call. But this is just a job schedule entry that show you what are the program, what are the tasks being submitted and when it will run, right? If you want to know what program it call, you put a file, display the detail, you will see the call job. Another way to schedule is actually straight away use a command called add job schedule entry. But most of the time we will use work job schedule entry here. And then when you add the, you can actually use F6 in the bottom here, which will trigger this command called add job schedule entry. And this is a prompt level, which is much easier to handle. You do not need to remember all the parameters. Okay. So putting a job in the job queue, as in summary, so you can add job schedule entry, and as we say, this job schedule entry will put into the scheduler, and this scheduler will put into a job queue here, right? As and when the time is correct. If there's no date and time, this is specified called scheduler, so that will definitely have a time interval there that you put on your queue, and when it's the right time, then the job will go into the batch job queue and it's being executed, right? So how do you check your job? You can check your job using this command called work job schedule entry if this is a scheduled job. If this is a submit job, so what you use is called work submit job, whereby you submit the job and see how the progress is being in the queue, is being processed, and so forth. Of course, when you want to see a job is being executed and being processed, you can use a work active job. And under the subsystem queue batch, you will see the job is at the status of running and so forth. Another way is actually called work user job, the same thing. You can see all your job is being processed. Another one is called work subsystem. I will go through this with you in later part using the live command to show you how all this run. Okay. So spooling, right? So basically a spool is being generated by a program. You go to a spool file, and then the spooling concept will send this to out queue. Either default is queue print. The out queue is called queue print. Unless you specify other queue, you can control that based on the job description or the user profile, which out queue to send. Okay. So you can also, of course, specify in your print file. So when the developer, if you, let's say you are a developer, right, you can actually, the default is right to queue print, right? So the default is actually spool yes, and it will send this as a spool file, and to which out queue, the out queue follow your job description, and what type of form. If you are operator, you probably know in the old days, we have this different type of form called standard form, 2P, 3P. So the system will ask the operator to change the form when the printer is loaded with standard. So then this program send a form called with a asterisk 3PLY, means 3ply. Then the operator, it will prompt a message to the operator and say, please change the form. So the operator will change the form, then they will reply the message called go or ignore. Then the system will print, and the number of copies of this reports being print. You can print multiple copies. Let's say 10 copies, 20 copies. Then the system will print a copy with a called report header. right? Schedule file admin when it's ready to print is once the file is being processed finished, from page 1 all the way to, let's say the report have 99 page, right? So 99 page, once it's reach the 99 page, this this will allow the printer to start printing, right? So save yes or no. The print file can can disappear. Once after it's print, it will be no longer in the print queue, so it will be disappeared. But if you specify save yes, the print file after you finish printing, it will retain in the print queue so that you can reprint it again, right? So this is where you wanted to keep the copy, and then you say save yes, and this can be further be used for archiving and other purposes, right? So device, what print device you want to use. So in the old days, we can specify which printer name. So again, it tied to your job. So in this submit job, you can actually specify which printer output devices you want to use, right? So this is how the mechanism work. How do you manage a printer out queue? So your out queue can be specified in the job name, the job that you submit. Your device, the same thing, your print device can be specified in the job, either one of it. Or it can also be in the job description. The job description can say, in my user profile, I can say which printer I want to attach to. This specified in the user profile level. Same thing with the print device, right? So again, it comes to user profile. This is where you can specify your OQ based on your workstation. You can or print device and workstation. You can specify those devices name, or you go to the device description, right? The device description use. Let's say you did not specify this 1, 2, 3. You go to this print device system value, but the system value by default is Q print, right? Or the OQ is Q print, right? And again, sorry. The system value for print device is PRT01. My mistake, sorry. The OutQ is QPrint, all right? So if there is nothing being specified, you go to PRT01. That's not always a 01, okay? So if you were to run the program in the workstation in the Q Interactive, again, it follow this same mechanism, how your user profile is being set up or how your job is being set up, right? So at the end, all this job ABC is run in the job queue, it's being processed, and it look at the priority and how it's being set up. And if there's nothing being set up, very likely it will end up in QPrint or PRT01, and this our queue. And if that PRT01 has a device attached to it, you start print device, you have that attached to it, then those full file will be printed out. Okay. So same thing, we run the interactive job. So if you were to run a report interactively, again, you look at your user profile or your job profile, any of this being follow this hierarchy, right? So at the end, a job out queue or queue print will be spool out if that report has been generated. Again, that spool file can be spool out to any device or it just remain in the out queue. Okay. Now this is where this is almost being run from your batch job, your interactive job. When you run that report, if there's nothing specified, it will default to QPrint or PRT01, right? And these are all in the out queue. If your subsystem QSPL did not start, right? So this thing will just stay there. But once you start the QSPL subsystem, and if there's a writer, which is a real printer that attached, you can issue this command called start print writer, and it will ask you for what out queue you want to attach it. Default, the writer, let's say PRT01 will have an out queue called PRT01. The out queue will have the same name as the writer, the printer, right? Of course, you can specify one writer have multiple out queue. So this out queue will send physically all this file to the writer, and then it will get printed. Right. So again, job queue spooling. So any job can actually have generated the spool, right? And IBM ship queue uses sequence number, right? Any job queue can be fed at any one time, as mentioned. This job queue will just run the job, and once the job finish, you will have an output. The output is based on the user profile or the job specification. Then this output will be sent to either PRT01 or QPrint based on that numbers that you run in the job, right? So one output queue can be active up to 10 printer at any one time, right? So the same out queue can attach to 10 printer, so you can have parallel printing, right? So any output queue can be fed at any time by a program execution. Same when you run the program, the output queue will be generated. Same like when you run night job. So when you run night job, you can specify which out queue based on the job. So certain developers, let's say when I run the payroll process, then all this payroll report will go to the payroll department out queue. So when they turn on the printer next day, all this report will be printed automatically, right? Similarly, when they run credit cards end of day, so all this report was full to the credit card department, and when the user come back to work next day, this report will be printed out, right? So all this can be customized and specified in the user profile or in the program. So that's and the for job management, right? For work management part for printer. Is there any question you can post in the job queue? Then in the chat room, right? Someone asked. There's a question asked by No Salika. Is this training get recorded? Zheng, did we record this?
Yes, exactly.
Oh, all right. So I think we can get back to them. Let's continue. All right. We will continue with the part one of the CL programming. Just bring up this. So we will start the module unit 16 called programming concept. This is very short. So now we are going through the last three modules of today's training, right, with the programming, right? So we will discuss about the concept, what is programming on IBM I, and the steps involved to create a program. So by end of today, you will probably able to actually create a small program and get it running. So I will actually do it later for you. So now, why we need to do program is because this will just give you an example. If you're an operator, you will need to, let's say day to day, you need to do a backup. And these are the things that is very mundane or routine. So every day you need to initialize a tape, right? And prepare the tape for the save object command or save library command. And basically what you need to do is you want to also save the journal. So what you do is you change the journal, you create a new journal receiver, you do a change to it so that they tie to a new journal receiver, and you want to save the old one. So you want to save object, save the detached journal receiver, and after you have saved it, right, you want to remove it because that will save out the storage spaces. So what you do, you issue this command called delete journal receiver, right? So every day you'll be repeating this four process in and out 365 days, right? So if you were to, of course, if you enjoy typing it, of course, this will be fun. But if you are those person that you want to automate it, you want to able to, to execute a program so that you can play games or you can do something else a more productive way, then you can write a small script to, we call automate this process, right? That's why this is called control language. CL is stand for control language. So you can actually automate this process to make things much easier. So these are the things that we call, if something is day to day, you can control it, then you can write a CL program to do it. So what we do is this four thing is, instead of typing the four commands every day, you can create a CL program. And this program is called midday, right? So basically it runs in the middle of the day. So I can create a program called midday and the object type is program, right? Probably I will not explain what are the object type here. So whenever you need to call this program, you can actually use this, execute this program called midday, when just issue this command call midday, then this 4 command will be executed, right? It will be executed, this 4 command. So basically, this is what we call a simple program, a program that define a sequence of instruction a computer can interpret and run, right? So step involved in creating a program is pretty simple. As any developer, right, you must have a ideas. There's a light bulb here. This is a laser pointer. So must have idea what you want to do, what you intend to automate or intend to simplify the process. So you must know what you need, and then you put in your ideas. So in the old days, when I was in the system 36 or in 38 program, the system is very slow. So we don't key in a program and test our logic. We have to do something called a paper run. We design everything in a paper and then put it there. And back in the old days when AS400 is still at the 46 megahertz and everyone, you have 5 developers, everyone sharing a development environment, you don't compile a program based on to test your logic. You do everything on paper, you put everything down, then only you do the coding inside, then you compile. So back in the old days, we were not allowed to compile a program more than 3 or 5 times, right? And if our bosses found out that we compile a program, use the computer to test our logic, we're in trouble. So that's where you put in the logic, you design the program, you put in the logic in paper, then you type into the system what you plan to do, then you compile the program and you make it run, right? But nowadays, CPU resources is so much affordable. I believe a lot of people test our logic on the system rather than we test our system logic on the paper. So this is needed to create a program. You need to have some basic knowledge of programming language. In AS400, I believe CL is one of the most simple programming language to pick up, followed by the newer Python and so forth. RPG is also another language that's very easy to learn on IBM I, right? So you have some knowledge of what is we call logic, common sense of logic. Knowing a programming language is quite simple, and a PDM tool is program development management, and SEU, source edit utilities. These are the traditional green screen tools. The compiler, CL compiler comes standard with the OS, so you do not need to purchase it separately, right? So a compiler for language in which your program is written. All right, I kind of saw a question asked, any reason why you cannot compile many times? In the good old days, the CPU clock speed is 46 megahertz. So everyone were to submit the job to run, to test the program in that slow environment. A program compile will take 5 or 10 minutes. Unlike today, it's seconds. In that days, if you compile a program submitted in Q batch and take 5 minutes to compile the program, if everyone to compile it, so if you will send it 3 times or 5 times, you will take out 20 minutes of the day, right? So that's why in the old days, you don't use the program, your CPU to test your logic. You have everything put in nice, but today is different. Today our CPU is in 2 gigahertz or 3 gigahertz. So compiling a CL program in the good old days, 5 minutes, probably today is just a few seconds. So we don't bother at that anymore. But in the old days, yes, if you have a 20 developer, everyone submit their job and let the CPU to design to fail you, that is very time consuming, right? So so rational developer for this is another one is very useful. This is where you can design the program on your PC offline. You do not need to attach the 5250 screen to IBM I. You can do all your program design, program logics, and then submit for compiler. And then there is a test compiler inside your PC that you can simulate we call the syntax checking logic testing. Once you are online connected to your IBM I, you can actually submit that and compile it and become an executable code on the IBM I once you have that online, right? So you can do, if you have certain development tools like Eldon, they can even have something called version control. It can allow you to do check in and check out of that source code, right? So you can track your version change, you can track your deployments code and so forth. Okay. So how do we do that? So on, as just like any editor tools, you do it on thing. You need we call a file. You create a source file whereby you keep your program. So in IBM I, for a CL program, we typically in IBM we follow this program called QCL source. So Q is the first character for IBM I object. It's a CL source file. So what you do is you create a source physical file called QCL source, right? Then you edit your program there, and you give the program a member. So this like you have a file inside there. There's a paper that you keep you tell the system how to run. So there's a member of it. So from that member, you can put in your program coding. Later I'll show you. So I say I want to specify this is a program like midday. This midday program is a member, and I put in this four command, and then to tell this is a program, I say this is a program and this is an end program. Inside this program, I have this false command, the command that I do, right? And I save it, and after that, in the book member, no, start PDM and start SCU is not free. Okay, it doesn't come standard. You have to buy the RD1, the rational development tool for IBM I, right? It's not free. Okay, so if your production environment, most customer production, yes, even on the green screen, it's not free, right? So on the okay, so I will show you this part here later on when we do that, right? So after you key in all this thing and you save the member, right? In the work object PDM or in this as we call it PDM tools, you can create the program by selecting option 14, compile the program. Once the program is compiled successfully, you can execute the program. Okay. All right. So I'm going to go through this with you. So just a little bit of here. So what we do is if you have a source member, a source file to keep CL, we call it QCL source. So if you have a source program, source file that keep COBOL, we typically call it Q COBOL source. And if it's an RPG source, we call it Q RPG source. And if it's a screen, we call it Q DDS source. A screen that specify a file, a component, whatever. TDS is a separate tools that we define, we call data definition language. So you define the data structure, you define a screen, you create a print file. So basically we use DDS for our print file, our screen file, and our physical files. Okay, let me just go through a simple demo so you know what I'm talking about. So I will switch you guys to the AS400 screen. Bear with me while I stop this sharing. Okay, and I will switch to the AS400. Okay. So here, what I did, let me go out. So again, this is the QCMD that I called up, right? So let me go out again and give you a print start. So again, here. So this is where we call QCMD. I have a command line cleanup here. So what I did is actually to begin with, let's say you are an operator, you want to try. So what I do is I create a library. A library is where you create a folder where you keep everything, right? So I create a library called AS27. So this will be my library, but to do more thing, I can actually press function key F4 to do it. So I say I want to do a library called AS27, and this is training library so that you know when other people see it, they know it's created by who. Created by Jason, right? So when you do that, right, you create a library. So when I do a work library AS27, then there is a description here called training library created by Jason. So people will know that this is being used by me, right? So to do programming, so I said just now, if you remember the thing, I need to create something called a source physical file. Again, I do not need to remember anything. I just press the function key F4 after this command. So then this will prompt me all the parameters it needed. So I'm going to call it QCL source. Remember just now? And the library is called AS27. Okay. So I do not have any member, it's okay. So again, I said this is a CL source file for demo purpose. Okay. So I can put my name here again so that people know this is created by me. Enter. So now I have inside the library, I have a source file called QCLSS. How do I know that? Right. You can use this command called work object PDM or start PDM. Right. Development tools. And I'm not going to see QGPL, but I want to see AS27. Right. So you see, this is the file that I created called QCL source. And how do I add a member to it? How do I add a member to it? There are many ways to do it. Right. I can use F6. If you can notice here in the bottom, you have F3 exit, F4 prompt, F6, F5 refresh, F6 create. Right. So what I'm not going to do that. So I'm going to show you a much easier way to do it. It's called Start PDM, Start Program Development Manager. Right. Programming Development Manager, PDM, and use option. Remember just now, if I use 1, it will show me all the library. So I can say all library, it show me all the library. It's very easy to show. Right, you come up here, 2, you show me the object in this library. So what everything in this library is called AS27. So if you option number 3 is where the source file that I created. So I use QCL source, right, that I created in AS27. Okay, so now you see there's nothing here because we just created a source file and there's no source here. So what I need to do is I use F6, create a source file. So now I'm going to press function key F6. All right. So now I'm going to create a CL program called CL program number 1. So I'm just call it CL number 1 and the source type is CLP, CL program. So this is a demo that I'm going to do it. I'm going to show it to you. All right. So now come in, and this is a very easy green screen. So for me, it's very easy. I just type program. Remember, I need to have a program and end program. I just come down here and then just put end program, just for the sake of demo here, right? So what I want to do in this program is very easy. Shall I just say send break message, right? Or I just do something called work active job. Okay. So in this program, I will just do something called work active job and nothing else. So when I call this program, the system will actually prompt me to work active job, and I'm done with it. I just press F3 and I just say yes and done. This is a CL program that you can see. I can use a file to show, or I can come out here. So what I do is, if you notice this function here, there's an option called 14, right? 14 to compile this program. I can, of course, display, I can delete, I can copy, I can print. So this is where the PDM tools come in, and these tools come along with the IBM development tools called RD1 for IBM I, right? It's a chargeable program, right? So now I'm going to do compile, but in order to compile, I want to make sure it stay in this library called AS27. So I'm going to put a F4 here to prompt it so that I know this program library stay in AS27, right? So again, if you want to know more, you can press F10. And these are, remember, where is the out queue, where is the user profile, and all this thing that we talk about in work management. So you can actually lock the CL program, allow retrieve CL source. You can actually don't allow people to see your program, right? So that they cannot do reverse engineering about it, right? So when you say allow retrieve CL source, no one knows what is inside this program. All the CL code will be hidden, okay? So now I'm good, I know what I wanted. So I just hit enter. So you see this program is submitted, right? And you say, you hear a sound tongue. So what happened is I can press F1 here, and I can see that the compile is submitted. This program is submitted to job and run in the batch job, right? So if I press F10, this is where I work submit job or work user job, and I know that this program is created, you see? Now, this member is compiled and submitted to batch and submitted to job, and it runs successfully, right? So I can see that this thing is being run. Now, To further confirm what I'm doing, I get out here. This is the source. I get out from here, and I come up from the source code, and I check the object in AS27. Is there a program running, being compiled there, right? So now you can see I have a CL1 program now in the CL program here running, and it's actually compiled successfully. This program here, if the compile doesn't success, it's not success, there'll be nothing. So how I know is again work submit job or work user job. You can see this CL program is being submitted, and I can put a 5 here to display my program, right? I can put a 6, right, or 5. Typically, I'll check the CL program. So it's being submitted, and it's a program compile listing is in the out queue. So what I do, I check the out queue. So you see this program is being compiled successfully, it's ready. I have an out queue, and I go to the bottom. I can see that the program CL1 is being placed in library AS27 at what time. And program sorry, I'm looking at the bottom line. The bottom line, you go down to the bottom last 3. So program CL1 created in library AS27, there's no error. Maximum error severity is 10, and there's no error. So that's where this program is successfully created. So what can we do with this program? So we can call it, right? So what I do is I'm going to call this program. So how I do it? Call, I place in AS27, and I call it CL1. What happened when I hit enter now? Right, when I hit enter on this one, a work active job screen will pop up. Let's try. See, the work active job is coming out, right? So this is a successful program that I just did, right? That's how simple it is to create a CL program, right? So if you doesn't like it, so what I do, I can delete this program, right? I can change it, right? Go back to the CL source, come back here again. But remember, I'm going to change this program now. So instead of work active job, what else can I do? I can say work out queue. Okay, now I'm instead of work active job, now I've changed the work out queue. So again, I can compile it again, and you submit it, and then you can press an F1 here and you can see what is the success is, right? And F10, right? So it's being submitted, and the members and everything is done here. So very likely is okay. So how do I call this program? I can also call this program in the in the work member here, start PDM. There is an option to call this. Let's see. Entry. Because my keypad is different. Change. I'm sorry, I can't call it here. I have to call it outside. Here. Yeah, 16. So I can use the option 16 to run this program. When I run this program now, what happened? Your work output queue, right? See, your work output queue. Right? So this is how easy from a menu screen for you to test your program, to create a program and run it, right? And to also examine what you have. Okay. So let's continue with the next slide. Right, so I'll start sharing here. Let me bring up the next one. Okay. Excuse me. So we'll talk about the CM programming concept if we go down a little bit more, because just now it's just a beginning. So a simple creating a CL program. But what if you want to do more? You want to do more complex stuff, right? So we will talk about all the basic statement in the CL, the structure of a CL program, and some of the coding rules, right? And also how do you communicate with your end user? Let's say you want to prop up a screen and let the user choose option 1, option 2, and option 3. Option 1 do certain tasks, option 2 do different tasks, and so forth, right? And how to set up a prompt for some of the CL command, right? We have prompt parameters, So all these are very simple. If you are very keen to do it, do attend the IBM CL programming class, or this we call uh, RD1 program. There we will teach you how to do all this programming in a more fun manner, and how do you test it, and how do you integrate with others, right? So just now we said, how do these compile into executable code, which I show you already, option 14, right? And how do you control what if workflow and so forth, and also put in the logic operations, and how do you interact with the users, and also you can allocate required resources, how do you run it, in which pool, which job queue, and so forth, right? So in IBM I, we have thousands of CL programs, of CL commands come along with the system. How are you going to remember it? Don't worry, you don't need to remember it. IBM I, you just need to know what is the F4 key, right? F4 will prompt you all these commands, right? Most CL commands are allowed in CL programs. Most of the standard that we use in the CL program, like GoTo, in the 101 of programming, we are not encouraged to use GoTo, but in CL program, it's such a simple thing. So CL is being used very, very frequent, right? A save library command, a verifying config, save object, send message, check object, start a printer, display message. These are some of the common things that we use, right? Of course, another one is call. So in the program, in CL, you can call program. Most of the time, in the night job, you call program A, program B, and so forth. And after you finish doing that, you may want to save the library and save object. And after process is being finished processing, you want to send a message, or you want to send a break message to the operator to tell them, let's check the printer and so forth. And then they will start the printer. And so these are the common program, or we call command, that you normally use in the CL programs. Right. Just now, remember my demo, I show you the CL program will always start with a program and end program. So in between their logic, you can say do something, then after finish, you can do and do, right? I mean, you perform a task, and then you end perform. And if you want to do certain, we call screen user logic. So what you can do is, if indicator 03, indicator 03 means if a user press F3, then you exit, you get out from the program. Else, you do something else. So this if-else is a logic that you actually allow you to process the user requirements, right? Go to label. If all this thing is not, you go back to the start, right? Go to. So you go to a certain label. I'll show you this one as well in the sample, right? Declare. So you may have processed certain variables. So you may want to say if 1 plus 1 equal to 2, or if this variable from this file is equal to or greater to something. So you can declare a variable, or you can change an alphabet, we call it numeric alphabet, numeric value to an alphabet. So you move something called declare, right? You declare variables, you can move it there, right? We call change variables. So these are in CL command. If you were to notice, sometimes we are so used to the AS400, we can actually bypass, we call the key, we call the parameters, or we call key parameters. So what happened is, if you save library, you straight away put in library name, right? So I can say save library AS2700, right? I know the first parameter is actually library name, right? And the second one is actually called device, right, which is here. So when I do save library, the first parameter is library, the second one is called device, and the third one is called end option, end of tape option, unload the tape. But if you are so used to it that you can actually do something called free format position. So I straight away say save library AS2700, which is a library name, and then I space it. I know the second parameter is actually called device, so I can say this is a tape 01. And the third parameter is called end of tape option. What I do, I'll unload it, unmount the tape. So actually you can do this way. So either way it works. And this same thing, this apply to when you put it into the CL program. If you do not press F4, you are so used to it, you can do this way, or you press F4, the system will prompt you these parameters, and you can key in them, key it inside one by one. This is the parameter that pops out, right? Remember just how I say all these command are available using F4, and all the command prompt. If you specify safe library, you press F4, all this command prompt and parameter show up as well. So you can key in very easily. Okay. There are some command that used to do formatting or before clear or initialize. So what happened is you can say, I want to clear a library. Clear a library means you remove every single content in that library, AS2700. Or you can take away this lighting, remember the free format? So you can say clear library AS2700. And there's a label. Label means that is where you can come back and redo it. So this is a label that you say, this line, just do this part, right? This label line. Now, there are quite a number of rules here. This presentation, because since it will be given, right? So you know that there are certain how these coding rules come in, right? You can do blank, that's example, safe library, just blank space, right? With the parameters. So with the parameter means the safe library with this one, and with the parentheses is where you specify the key thing, right? Remember, just I'll go back here. I do not specify anything without the blanket, right? Here you can actually use this parenthesis here, okay? Slash, and slash is where you specify the library and the program. So work object, this is library name, and this is the program name midday, right? And similarly with the directory as well, right? So there are certain things like when you send a message that say program completed to this user QPGMR, right? You will do this way. You have to specify it. If you cannot remember, don't worry. You press F4, and F4 will help you to fill up all this apostrophe, the parentheses, and so forth. So basically, as I said, the most easy and commonly, even for me as a seasoned developer, most of the time I still use F4 to do it, to ensure that I don't make any mistake. Right now, this one is very I call, if you're very seasoned, you know all these things. That's what you do. Safe library AS2703. You use a tip one, and asterisk and asterisk. And for me, I can't even remember, but I have to do a prompt there to know. Meaning that you just take the null characters. Okay. So generic name that you want to save library more than that. So basically, what happened is when you, this is the last one, save library AS27 asterisk. What does it mean? It means it save everything start with first four character AS27. It can be 01, 02, 03, whatever. The first four digit match. The remaining I don't care. It will be saved into a tape. Okay. And this one is called the second last, save library asterisk all users. In the IBM I, they have actually categorized user library and system library. When you say asterisk all user, you will save all the users library, right? And you save it into a save file instead of a tape drive. Okay. And you can put remark. So this is a remark that a command. You put everything in this slash asterisk and then slash asterisk slash here. Whatever in between there is actually a command, right? A variable you can declare. Remember just now we said there's declaration here, DCL. So when you do DCL, you can actually put in this and sign with this variable name. I'll show you later on, right? A colon is separate a command label. Okay. A plus and minus sign are where you can do subsection and minus, right? Or you can continue. If this is a line that's not enough because we only have 80 column or 130 column, if that line is too long, you can use this plus or dash sign to continue the next line. Okay. So now this is where a sample of the coding. Remember just how I show you program and end program. This is the most simple to start a CL program. So I can say I declare a file. This is actually a screen file. So you can see AP DSP. DSP is a screen file that allow user to choose 1, 2, 3. So if option 1 is do a DFU program, option 2 is call this program APR200. Option 3 is run a query called APQ42. If the users choose 90, option 90 in the screen, basically the system service sign off, kick you out. Otherwise, if all this running is not, what happened is go to, remember this is a go to command label start. Where is command label start? This is the one. So it go back to show you the screen and wait for your input, right? So this thing will continue until Either indicator 03 means F3. So indicator 03 F3 means return. Return means get out this program. So this program will not be run. Okay. So this is a very interesting program that later on I will run this program and compile this program and let you see how it works. Okay. So basically, is to start a program, you say program, end a program, end program. The in between, this is where you declare variables, declare a file if you have an input file. You can declare variables. You can declare monitor message. Basically, you want to monitor what happened if a bash program executes successfully or non-successfully. What you want to do, right? This is where if else. So again, if else can monitor a program message. Basically, if you submit a job, if that job runs successfully, then only you continue the next job. So you will monitor the run message. If that run finished, then you continue the next one. Otherwise, you will just return or you send an error message to your operator, right? So this is how you do a control in your batch job. Declare a CL variables. A CL can have basically 4 types of variables. So you can say this is a decimal. I mean, this is a numeric decimal. So you can have 1 to 15 digit, right? You can default the variable, right? 15.5 or max 15.9. So you can default the value, the length of the variable, and also the value. You can set the default to 0. Integer. Integer is again is a numeric, right? And you can have up to 2 or 4 bytes. You can have a default of 0. And most of the time, we use this decimal or character, asterisk, CHAR. CHAR is actually a alphabet. So you can have default upper and lower character, right? You can have default length of 32, this is a length, maximum of 49, meaning the length of 9999, right? So this is how long the character can be stored. And the last one is logical. Logical means either 0 or 1, yes or no. So you can set this default. The default length is always 1 and max is 1 because it's yes or no or 0 or 1. So you can see default to 0, meaning it's off, right? So a sample of it is like this. You can declare a variable. This is called a ampersand sign A, right? And it's a logical value. Value 1 you set to on. Basically, this is the last one, right? And declare a variable. This is in detail. We call it ampersand B, and it's a character. The length is 5. And I want to put in a value called ABCD, right? Again, the last one is declare variable C. It's a decimal. It's a decimal which have a 6 and 2 decimal places. So I can set the value 543.21. Right? So basically, this is how you declare a variable in the CL program, right? Okay, this is how it works, right? Again, if you remember in line 2, you have this slash asterisk, yes or no. This is where it's called a remark. So you can declare this ampersand X is a character. You can set it default value to 1. Remember, 1 is yes and 0 is no, right? And so forth. So what's the purpose of send user message? Basically, you want to interact with the users. So you can say, which library do you want to save? So then this user will reply, oh, okay, maybe I want to send it to AS27, right? With this variable, you can pass it back, and then the CL will capture that, right? So you can say message text and up to 20, and message type and so forth to which users, and message reply. So when the user reply, you can store in this CL variable. So let's say I reply and I say this is a 10 character length CL variables. Then you say AS27, this 27 there. Then you can actually say which library do you want to save, and the variable come back and message reply and this library. And then you can actually save using this command. The following is actually save library. So the user will tell you which library to save, right? So again, this is a very interesting CL program. So I declare a variable called library. I have a character of 10, as I mentioned, and I send a user message say, which library do you want to save? And you will reply, right? Valid replies, even restricted. So valid replies are AP library or payroll library or INV library. So the value is set. So you actually have a checking. The system, the reply message allow only these 3 valid variables: AP library, payroll library, or invoice library. So then you say message reply into this library list. This was the one that we say these variables. So when the reply is being hit back, so straight away you can save library. The library is this is the parameter that reply by the end users, and you can save it to tape drive 1. And during the end option, you unload that cartridges. So after this is done, you can send a message say send message library successfully saved to the requester, the user that actually run this. Right. So this is a very cool sample program by leveraging the command called send user message. Right. So this helps you to achieve a program, a simple program that perform a save library task. All right. So what the if then else logic, right? So basically, you say if condition meet number 1, right? You do this, else you do something else. So if condition is either a naming, is a name, let's say AP library, then you save AP library. Else you just go back and say error. So this is where you can execute the next command in line. So if else is a very simple thing to do. So here it goes. So what we do is if the value is equal to y, you say call weekend job, they call a weekend program, else you call a month-end program, right? So if the initialize tape is equal to OK, you start initialize tape and check no. Else you start creating a save file. Oh, I mean that you're not saving it to tape, you're saving the save file called delay daily number 1. So you start saving the library XYZ into this save file, daily number 1, and then go back to call the program A, right, and this undo. So basically this is a set of if else sample command that you actually can program your CL, how you handle different situation, different requests, different conditions, right? Of course, there are more in the if else statement. So you can compare a variable. If this is less than operator, you can use this operator on the left hand side. So these are the operator we call a shortcut mean. If you do not like to type everything in character, you can actually either one will work. So if a variable less than, you can put asterisk LT or as just this less than sign. Equal is this equal sign or asterisk equal, and so forth. So you can say this is and not. What if not equal? Not equal is equal to, you look at this sign here with that length here and is equal. This is what you mean by not equal or not not is this one, right? So for me, I normally typically you can either use this one here or you can use the middle one with the asterisk or asterisk and not equal and so forth, right? So these are we call the expression operands, right? So this is the one that say if this variable x equal to yes, you can use the similar one. What is it? Equal is asterisk eq, right? And this either one of it will work, right? And now we're going to the next one called do and undo. So again, if you notice that the previous one, if can only do one action, you cannot do multiple action. So you want to do multiple action, you use this command called do. So if the condition x equal to yes, you want to do create save file, save object, then finish. So in this feature, you are performing two sequential tasks. The first one is create save file, the second one is save object, right? So this condition here, you ask the system to do this thing, only after that you go back to the if condition, right? Command prompting. Command prompting is very interesting. So what you do is if you cannot understand or you don't like to press F4, you want to let the system automatically prompt F4 to the end user. So what you do is in this command here, send program message, you can actually put a question mark sign here, send message to users. What happened? It will prompt the user. Okay. I'll show you a demo later, shortly. So to this which user. All right. Okay, what we do is like this one. One with one question mark and two question mark actually have different thing. So the one question mark is actually you cannot change the parameters like this one. It's protected this field. And the two question mark here, two question here is actually it prompt the parameters, but you can change it, right? So let's do this later. Okay. And let me go to a sample to show you what happened. And this is what it means. So you can do this in the CL program, or you can do it here in the command line. Let me just press F3, go back to command line. So if I were to do this prompt, save library, right? And I do not know, so what I do is I want to put this one, as I said, library. So I keep it here, let's say AS27, right? And I want to put one here with asterisk, which I'm going to protect it, right? TAP01. So now when I hit enter, what happened? Okay, sorry. Let me just say it's not the right prompt. What happened is it will prompt me. See? It will prompt me because it will force the system to prompt the user. So I did the wrong thing here. So let me press 11. Right, remember to show me library and device. So I made a mistake just now. So let me go back there. I retrieve it. Okay. So what happened is I make a mistake here, meaning I have the first one library correct. Yes, 27. But I have this wrong. It's a device. Okay, AB01. Okay, let's see. I have now. See, if you do that now, I have an input parameter that I can change, right? But if you notice the device is something that I cannot type at all. It's being protected, right? So that's where when you prompt a message via the CL program, you want to show this to your end user, and you don't allow them to change the tape drive. What you can do is you put a question mark here with an asterisk with the parameter prompt. Then that line will be protected as what the screen showed, right? Here. So this TAP01 is being protected based on the previous command line. So here, this one. So sorry. Okay. Shift library, asterisk library, AP library, device. I protect the device, and the rest it allows the user to change it. Right. This is how you can do it in your CL program. Okay. Similarly, this one, you can actually capture that message. Right. Remember just now there's a previous one. Which library do you want to save? Valid replies are AP library, payroll library, and invoice library. Right. When you reply here, actually it has a checking. Remember, right? So it only allow you to key in that one. So again, let's try to do something called a meaning monitor the message, meaning monitor the reply. When we try to clear a save file that might or may not already exist. If it doesn't exist, create it. So what happens is like this. When I create a save file and this save file doesn't exist, I want to capture the error message called CPF9812. And if this save file doesn't exist, the system will generate an error message called CPF12. And if I see this, what I do, I create a save file called APSave, right? So how do you know this is the CPF9812, right? So it's very easy. So what we do, I go back to the demo again. Let me just stop the sharing and go to the screen. So again, I will try to clear a save file, right? Let's assume this has never happened. So I just call 27, right? 27, I put in there JSON, right? So you see, this is a JSON file that's never exists. This is actually a message file. So what I do, I go to F1. You see, this is a message ID called CPF9812, right? And the error code is severity is 40, right? So this is definitely, if you were to do this, your CL program will hang, right? You definitely hang. So let me try to do it for you now. Sorry. So let me create a CL program. Go back here, start PDM, and let's simulate that. Okay. We'll do a demo. Okay, let me create a new one for F6. So I call this program clear save file, the CL program, and clear save file demo, right? So again, program, and for this program I have very short, so I do end program here. And I just need to do something called clear save file. And again, I put a F4 here, I don't remember. So I don't need to put anything. So I just want to say clear save file AS27 in, okay, just put in JSON here, purposely to, and AS27 demo, right? This is where my demo library. Okay, so this is done. So I compile this program. Okay, so this program is being compiled and it's being submitted. I know it's definitely run. So what I do now, I call this program. When I call this program, what happened? See, you see the error message, CPF 9812. This is where it stays. The save file, right, is trying to, this inquiry message is that it's trying to detect an error. So what you do is you can display the message detail by pressing F10. So file JSON, right, in library not found, and you press an F1 there, you know, you get CPF 9812, right? So what do I do now? Just simulate what we do now. We change the program. So now I just cancel my program. It's not going to run. So I come here and I change it. So what I do now, I'm going to do something similar to what the training material take, right? One message ID is CPF 9812. And I'm going to execute something called create save file in the same library. So again, I press an F4 because I do not remember everything. So this save file is called JSON in AS27 demo, right? Okay. So this is exactly the command that is being shown. So AS27 demo, I'm going to do JSON. So let's do it now because we all know the JSON save file is not there, right? When we execute this program, let me compile this program, right? Replace it. So now when I execute this program, now let me, before that, I will do something called work object PDM and show you that the AS27 demo library do not have a JSON save file there. There's no JSON save file here. You can see there are two files here, but there's no JSON save file. So now I'm going to call this CL program called create save file. Now you see there's no error message anymore, right? But if I come back to work object PDM, AS27 demo, I will see a new object now. It's called JSON. See? JSON save file is there, right? Why? Because just now we tell the system, when I try to clear JSON save file, there's nothing there. If success, you will not have this message. But if not success, I'll create that, right? So I can do something here as well. So let me show you this how this program run. So I can save object here now in JSON save file. Save object. Let me from it. So object called QCL source or asterisk. I don't care. Whatever inside that. In library called AS27 demo, right? I call it save file, right? And then it will prompt me for the save file name for JSON AS27 demo. So now I put something there, right? So display save file AS27 demo JSON. You'll see that I have an object being saved here. It's a source file. But what if I run again? If I run the program again, sorry, if I run this program again called save file, what happened? This program tells the system I need to clear the save file, meaning I wiped out everything in JSON 37 demo, right? Let's do that again. So I call it. So what happened? I retrieve the save file, display save file command again. Now you can see there's nothing inside the JSON save file, right? So basically this is what the program is trying to do. It's a very simple CL program that it basically clear the save file and do a, when it cleared it, it just clear. If it doesn't clear, it will create a one save file for you, right? That's all. Okay, let's move on back to the slide. Okay. So this is how cool it is to run a save file to create something in the CL program. right? I believe whatever I show you, is nothing rocket science. It's very simple to master and actually do it yourself. So message CPF00 means you monitor all the message. You don't care, so that to ensure that the program will not crash, right? It will not crash the program, right? So if you monitor all the CPF3400, meaning you monitor all the message begin with 34 CPF34, right? So again, this is another sample. What you do is this sample doesn't monitor any message. What happens is this program initialize the tape device. So initialize the tape inside TAP01 with the volume called daily. And one is successful, you can save library. And these are the two libraries that you wanted to save into this device called tape01. And once the finished saving, it will unmount the tape called unload. And then after that, you will call a program called pay end of day. So you process that end of day process. Hold on, give me a minute. I think I saw someone ask a question. Let's see. Yeah, I can't see it here. So there's a question asked. Okay. In CL programming, you can just type at any position. I mean, if RPG, you have to position the key code. A good question. Let me, yes, you can type in anywhere. Right. The CL is much easier than RPG because RPG you go with the same as DDS. There are certain positions in the screen. Depends on the type. We call the prompt. Again, both CL or RPG. Always remember AS400 is not rocket science. It's very simple. Always remember you just hit F4. The system will bring you to the correct we call column and position. So you don't need to worry. But in CL, yes, you can just type there, no worry. Right. But in case you're very worried, let me show you how you do it. Let me just switch again. Okay, let me just create a new one. You can see the screen here. Let me just create. I press F6 to create a new one, right? So that JSON demo 2 or CL program 2, right? It's a CL program. Okay, so you can type anywhere if you want to, and you don't need to worry about error, except that these are not keyword. If this is not keyword, you will see error in the yellow sign. But if this is a keyword, you can type anywhere, there's no issue, right? I can type, I take away here, I can come to the end of it. I put end program. As long as these are a valid keyword, you don't get anything. But what if you do not know what are the things to put in, right? So you can prompt here. You can always put a P here. Remember the CL command, you do not need to worry about it. So I can say, I want to start with program. So actually, you do not need to start with program. It's okay as well. So I say, I want to find initialize tape. Oh, sorry. You can select, sorry, it use here. So I can say, I want to find initialize tape here. Then it will show you all the initialize what you want to do. So same as select this one, right? It will prompt you. You don't care, you just do it there. Let's say ABC, like that. So the system will already give you initialize tape with that command, all right? So for us, because we know Q6 is not there, so we just take away this one, and you can further prompt it, okay? Again, without end program and program, this is still a valid CL program. Let me show that you can compile it, no problem, right? So you can compile it. Wait, let me see what I missed, because there is a program. Okay, here. So it's a CLP2, so I can compile this program, 14. Yeah, I see the program is being compiled and no problem, right? So how do I know work submit job? SPM. Right, I can see a CLP2 here. Right, let me check the spool file. You see the spool file one line mean is okay. The program is being compiled successfully. So program CLP2 is being created successfully in this thing with no error. Even you don't have a program and end program. You see the system is so smart. It tells you here in the top two lines, it say a program command is missing, an end of program is missing, an end program also missing. But this is acceptable, right? This is allowed in a CL program. So basically CL program has more fault tolerance than the RPG, all right? Okay, let me go back to the presentation now. right? We stop sharing here and go back to the PowerPoint. Okay, so let's continue where we are. So basically, this is a simple program to save and run a process. Okay, so another one which actually you want to interact with the user, right? So you can declare a variable. Remember just now you want to say, do you want to save which library? There are 3 library lists, right? Now you want to say, I send a user message, tell the user, do you want to initialize a tip? Yes or no? You can see the valid value, meaning the system will automatically check. If there's not Y and N, it will give you an error message, right? Sorry, I forgot my laser pointer again. So in here, you can see that I have a command label called again. All right. And I declare this variable, return variable called X, which is a character with three-digit length, right? So I send a user message to the user, say, do you want to initialize a tip? Yes or no? And you reply the message and input in this variable that you declare called ampersand X, right? So if the condition is equal to yes, then what you do initialize the tip and you issue this command called initialize tip 01 new volume daily. And you go back here again and send the users, do you want to initialize tip? Yes or no? If the user didn't do anything, this will keep on in the loop. Otherwise, you come here and do, right? And if the user put no, what happened? It didn't come here. If the user put no, second round, it straight away come to save the library. So what library you save? You save a library called payroll and AP library into this tip drive tip 01. And once it's finished, you say, send user message, the payroll and AP libraries have been saved to, and the message type is info. Remember that the message type different. There's a different type we call message reply and message type. So basically you send the same command. One is you call message reply, you are expecting a reply. The other one is just inform them. It's an information message. You are not waiting for any reply, right? And then this program will run. When you execute this program will always prompt a user for inquiry call, do you want to initialize, right? If the user said no, straight away it will just save the tip, right? A very useful program. Okay. So I've actually show you how do you enter CL program using PDM. How do I do that? Remember, so I said start PDM. So start PDM, you can enter the CL source. And just now there was a question asked, is that tool free? It's not. So you need to purchase it using an RDI for I, right? And this SEU and PDM come together with the RD license program, okay? So how do you compile it? If you notice, I never use this command called create CL program. I use option 14 to compile. You can use this program. Again, you need to prompt it. You can do, it's more tedious, but for seasoned developer, they normally use CL, recall a CL command. They issue this command called create CL program and they compile it. Otherwise, you may follow my style. I just use option 14 to compile it. Now, why we introduce this to you? In the event you do not have a RD tools in your production and you want to create a CL to run it, what you can do, you can use your we call the text editor or notepad on your PC, right? You key in all this CL program and you create a source file on your production environment and you upload this source member into that CL source. And you can use this command called create CL program to compile it without using option 14. All right. So this is one way that if in the event that you do not have a RD tools in your production environment or environment that you didn't purchase a license, right? Let's say your DR environment, it doesn't have a license to do that. So what you can do, you can still create or compile a CL program without the RD tools. Okay. So that's and the basic of this module, right? So we basically cover how do we create basic CL program, and I'll also showcase to you how do we do that in the actual environment. Let's see. A minute. Let me end this slide here. Okay, let me look at your question again. Just give me one moment. Yeah, I'm checking. Do you guys want a short break before we go to the final one? How do we use PDM and SEU? I think we take a 10 minutes break. Then we will wrap up the last module, right? Oh, okay. If you want to purchase a license, you can talk to CBS if they are your business partner, or you can come to IBM direct. There will be, one IBM representative to individual company, so you can contact IBM or you can contact we call your business partner CBS. All right. I think let's take a short 10 minutes break, then we will pick up the last module. Then we wrap up the day, right?
Okay.
Yeah.
Okay.
So we resume back at 3 p.m.
Yep.
Okay. Thanks.
So come back at 3 lah.
Okay. Welcome back, everyone. This is toward the last module of today education's session, so it won't be too long. So we can finish everything by before 3:30, so that you guys can continue to do what you would like to have, right? So let's begin. So what we're trying to cover is actually how do we use the development tools that come with the IBM I. So the tool is called Program Development Manager, and SEU. SEU stands for Source Edit Utility, right? So actually, some of you have actually shown it. I mean, as using it, and just now I did showcase it as well. So how the unit of this is actually to show you or give you an overview of PDM and SEU and how do we create CL program, and use a from for CL program statements and so forth, and how do we step to compile. Basically, you notice it's actually showcased to you earlier, but what we need to do is go in a little bit detail, right? So when we start this command, is actually very easy. How do we come to here? It's called strpdm, start PDM. So start PDM will bring you to this screen here. You can check the objects in the library. You can check the objects in the work with object PDM, and you can look at the source member, right? So which I show you to now just now using QCL source AS2700. It will show you all the members here. And if you notice just now, I did use the option 14 to compile it. And I can copy a source member if I want to. If I use option 2, I can edit it. If I use option 5, I can display and not editing it. And if I do not want that source anymore, I can delete it. And the best is you can actually print it out. So, in the old days, we do print it out and we are off and we want to check our program back home, we can check our hard copy, right? Of course, this one can also be printed for someone to check your program, right? So again, you can rename a member, right? And you can save it and so forth. And the option F6 is where for you to create a brand new source member, right? So when I press option F6 here, and then it will come and we will start creating a program that we mentioned earlier called Midday. So I'm going to create a source member called Midday, and I'm going to call this a CL program, and it's a program to back up a journal receiver, right? So remember in the earlier unit, the program basically do perform 4 tasks. Initialize tape, change the journal receiver, save the journal receiver, right, using set object command, and then delete the old journal receiver, and that's done, right? So when you do initialize tape, you can press F4 next to it, and then you prompt you for the tape devices and how you want to run the tape. After end of tape option, you want to rewind it or you want to unload the tape, and those are the parameters that you can specify in the initialize tape command, right? So after you have done, if you look at the here, so basically developer or the operator, whoever that do this source, he can actually key in all the correct parameter. Let's come back here and look at it. So he said initialize tape to using a device tape 01, and I'm going to call this volume for midday and check no. So straight away initialize the tape and change the journal. The journal is called AS2700 and in the library 2700, sorry. And journal is called JRN all the 01, and journal receiver is JRN 002, right? It's going to change this 001 with 002, and I will save the object called JRN receiver 001 in library AS2700 and to the tape price 01. Right, once I've done it, I will delete the general receiver, JRN receiver 001, and that's it done. Right. So basically, once you do that, you press F3, then you will do exit. F3 is exit here. If you look at the left hand side, F3 is exit. Then it will prompt you this exit screen, whether you want to change and save the member that you just created, right? And then you resequence, you can resequence this number here, right? Then once you're done, you can put option 14 to compile this midday, right? And again, you can press F4. And when you press F4, it's basically prompt you the screen here, create CL program. Remember, like I said, if you don't have a PDM, you can actually use this command called create CL program and put in your source file, your program name and source member, right? Replace the old program. If that program is already there, you can replace it. And basically that's done. So you can create a program that what they didn't show you, you can actually put a C here to call this program, right? So basically you can do a C here to call this program as well. So basically that's it for creating a CL program. It's very, very straightforward, right? So again, where do you get reference material? So as I mentioned, IBM has provided a lot of sample program, a lot of details on all these things like top authority, how to initialize tape, and how do you do backup in the Knowledge Center. Again, if you like to learn more about programming, if you really like, what I show you, an introduction, right? You can actually go for a programming workshop, which is the class code OL20G, right? It's a 4 days workshop that we can run this for you or your colleague. It can be at your site or it can be like what we do now because of COVID-19. We can run a workshop to your developers or to your group of operators. And again, if you are more curious about other programming, for instance, RPG4 programming, and this is a very interesting programming because we are now expose RPG as the service program. So you can actually let your internet banking, those other program, to call your RPG program and return the value so that instead of they write everything in Java, they can actually leverage whatever you have and expose this RPG as a services to them. So RPG program will have a little bit of that, talk about how do you use the conventional RPG as a services program. If you like to do that, then probably you look at this RPG4 programming. Right, this is a fundamental. They have another one called the advanced as well. Okay, so that basically sum up the we call the module today. What I can show you, because we actually cover quite a bit, but what I like to show you is this one. In PDM, over here, if you notice that how you're going to know what is happening in PDM. Say for instance here, I come here, I know C is called this program, right? How do I know that C is here, but there's nothing show up here, right? So what you do is F3, go to the main screen, is option number 9. That's where you can see what are the options there you can do. Remember just how I said C, I put a C there. The C is actually tell the PDM tools that I'm going to call the program in that library, right? And you can have A, B, A, D, and all these things. All these things are all customizable, right, in your PDM, right? So in here, I can say SP is work tool file, WS is submit job, right? Let me go up here. I go to 3. Now in this format here, I can say work submit job, WS, right? See? So this is what it means just now in that option. All right. So this is a fun tool to use, and I use it a lot, right? So on and off, I cannot, because every system user customize it. This is a register system. So my colleague in register may have use the default or customize this, right? Okay, is there any question that you would like to ask? Okay, we didn't cover the screen. If you want, give me 5 minutes. I will show you how do we do the screen. We didn't have a screen entry just now, right? So how do we do screen? It's actually quite easy. Start screen design A. I can design a menu or design a screen. So what happened is, let me go back here. I have a program that I did halfway that's supposed to do a demo to you. This is a program, AS400, right? Which I have a screen file that's not using, APDSP001. So this program did not complete. So let's do that now. So I'm going to design a screen and I'm going to create, I do not have a DDS screen. So what I'm going to do is create a source file in AS27 demo called QDDS as source, right? So I'm going to design a screen called QDDS source in AS27 demo. So this is the one that we say ASP ESP001, right? Okay, so I'm going to call it format 01 as per the system, right? And this is where I define my screen. It's very easy to define it. So I say this is a date. I hit enter, it show a date. So, and this is my entry screen. So I'm going to say JSON demo. And then here, you just stay here, and then I can say, now this is, remember this technology is actually 30 years. So this thing automatically based on what you design the screen, it generates a source code. So I said this is a time, or this is a time. So from here I can say, all right, I want to do option one, do A, do let's say work output Q, right? And this is my option one, and I have the option two, work drop, right? And then option I0 sign off. Okay. So this is the thing. So what I'm going to do is I'm going to have the so over here I will put in a value called option. Oops. I may have mistaken. It's been a long time never use this. Okay. Give me a minute. It's been a while I never use this. Try this. Okay, never mind. There's always ways to do it. All right. So I can save it. So let me go back and check my screen. Okay, this is how the SDA do is called screen design A. It will generate the source file for you. So if you go back to PDM, start PDM, you'll see that if I go to QDDS source, and this is the screen that I created just now. It's called display file, and I can put a 2 there. Sorry, I can put a 2 there to see. This is a screen file that is being generated, and the screen size of this thing. All right. So there's one part that I missed out is actually how do I create an option key? It's been a while that I not do this programming. Just give me a minute. Just give me 5 seconds. I cannot remember. So what I need to do, I just go into search for help. Need to put in the variables. Yeah. Okay, here you go. So I need to add in the variables. So what I do is I need to do a plus BBB is both input and output. So yep. So let's do it. This is where I forgot, right? So this is where I do. This is where the value I bring in. All right. So this is how simple it is, right? By pressing F1 and F3, see it, and now you will see that my source code will have a very different. Okay, save it, enter. Okay. Okay. When I do a sub PDM, sorry. I check my DDS member, then two. So I will have a field called FLD001. It's an alphabet, and this is a field, but I do not want this field called FLD01. So I want to call it FPD option, right? It's a 3-digit length, right? So I've done it. Then I have 3 out. Yes. All right. So I compile it, replace it. Okay. So I have ASP DSP001. Now I go back and check my CL source. Okay. Okay. Let's look at this one. So is the format is FMT01 ASP. Okay, it's ASP DSP001. Okay. This is my program. And I have an indication of 03, which I didn't put it in, right? So the field is actually called option. So which here I'm not going to call option, I call OPT, because I named that field OPT. Okay, so let's compile this program. So smooth file, see whether I compile it successfully. So 8 here. Now you see I have an error. If I have two smooth file means I have an error. Let's go down and see what are the missing part. No variable declare. Okay, where does it go? Page up. See, oh, these are the variable. OPT is not there. Ah, okay, my ASP DSP001 is not in the library. It cannot be found. Okay. That is a very simple issue. Add library list entry AS27 demo. Because it's not in there, so I recompile again. Cannot find my library list. Found. Okay. What else is missing? Operands in there, not the same type. All right. Yeah, see now I have the file that's defined, but because what happened is earlier I defined that variable as numeric, but now I refine it as a character. So this is where the problem is very simple. So let me just delete this one, go back. So to fix the problem is very easy. Because if you are a character, what you need to do is you have to ensure that this is a character equal to 1. Right? Maybe do an insert here. All right. The same thing. I need to ensure that this is this way. Same thing. So this thing more tidy up. Okay. Sorry. 4, 3, yes. So compile again. This should make things work now. Oh, something else. What is not right now? 40. There's one more error that I make. Let's see what this is. Variable 30. Remember, I do not have the F3 created there. So yeah, this is a mistake I make again. Because I didn't have the F3 defined in the display file. But for now, I'm not going to save time, I'm not going to do that in the display file. So straight away, I will just say, I'll just take away this one. All right. So I just say if this way, this way, this way. Yeah, now it's successfully run. So what happened? Let's call this program now so you can know what happened. So I'm going to call this program and voila, see, I have a display screen and look at the time, right? It's today time and so forth. So if I do 01, it will do the workout queue, but bear in mind just now, I didn't change workout queue, I didn't do all this thing. So just, I only make one mistake, I didn't change the program, right? So my program will not do workout queue, will not do 02. Let me do a sign off, 90, I'm not sure it will work, right? So, well, 90 is over, so I make a mistake then. So my program has bug and I cannot do something, right? So what I do now, just a minute. So I need to call a system request to terminate this program, right? So what I'm trying to do here is basically, you can see that my program actually run, but I didn't change the action. Just give me a minute. Let me pops out the system request key. Sorry guys, because this is new keypad to me, I can't find the system request key. Just a minute. Okay, system request key 2, enter. Okay, this will end the program, right? So what happened is here, if my 90 is supposed to sign off, it didn't, right? So this is a mistake that I make. Let me just, right? And here, you see, I didn't do that. So what happened is the first one, I do an F4 here. I will say work out queue instead of doing anything else, right? There is an error here, no worry. Bother about it first. Second one, option 2. All right. Let me just prompt it. So if I do option 1 now, you will see that I have, it doesn't meet the thing because I think my value is not correctly specified. My mistake here. So that's where you need time to do debug. Now, due to time constraint, actually you can do, there's a tools that we call add breakpoint and debug that you can show the screen value, right? So, but due to the short of time here, because there is another event happening at 3:30, so I have to end the demo here. So what happened is I will do this tomorrow. I'll fix this program. I'll show you tomorrow. We'll continue tomorrow. Yeah. So for now, I think we will just end the class here. And I will surrender the time back to CBS. Yeah, I will fix that program and I'll show you guys tomorrow. Yeah, my apology for that.
Thank you, Jason.
Yeah.
So we will end the training today, and we'll start same time tomorrow at 9:30. But should you have any question, you can still send it to us or email us. Tomorrow, Jason will show you the program set for the CL programming. Okay, so we'll see you tomorrow morning. Thank you. Bye. Thanks.